Hello,
Hello, hello, hello, hello,
hello,
hello, hello, hello, hello, hello.
হ্যালো 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 চেক চেক হ্যালো হ্যালো চেক হ্যালো হ্যালো চেক 1 2 ঠিক আছে হ্যালো 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 চেক 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 হ্যালো 1 2 হ্যালো চেক 1 2 হ্যালো
অন করে দিব কোথায় থাক কোথায় থাকবো ওরা আচ্ছা কথা হচ্ছে মাইকটা স্পিকারের সামনে যাওয়া যাবে না সামনে গেলে বিকট শব্দ হবে কিন্তু হ্যালো 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 হ্যালো
হ্যালো, হ্যালো,
হ্যালো প্রেস করে ধরে রাখতে হবে লাল বাটনটা প্রেস করে ধরে রাখলে জাস্ট 3-4 সেকেন্ড ওকে অন থাকবে বাট কোনো সাউন্ড বের হবে না এটা তো বেটার আমরা যখন হচ্ছে কাজ থাকবে তখন মিউট করে রাখবো হ্যালো 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 হ্যালো
এটা না সামনেরটা, এটা কোনটা? Excuse me, ভাইয়া একটু ভাইয়া একটু
মাইকের সামনে যাওয়া যাবে না, তখন আমার পিছনে থাকি, যখন হচ্ছে অডিয়েন্স হ্যান্ড রেজ করবে আমরা তার কাছে যাব। হ্যাঁ হ্যাঁ আচ্ছা ইয়া করেন দিবা, ওই যে ওদিকে রাখি এটাও। ওকে করছি।
আসসালামু আলাইকুম সবাইকে। আমি রিকোয়েস্ট করছি সবাই আসন গ্রহণ করার জন্য। উইল স্টার্ট আওয়ার কনফারেন্স ইন এ সেকেন্ডস অর সো। Can we request distinguished guests, conference speakers, faculties, participants, guests, Assalamu alaikum. Very good afternoon to everyone and all present here, and thank you for joining us at the first International Conference on Textile Science and Engineering 2002, organized by Faculty of Textile Engineering, Bangladesh University of Textiles. It's my pleasure to hosting you through the conference, introduce you to the speakers and delegates that have come from all over the country today to share their knowledge and enhance our intellectual capabilities. In today's conference, we have 46 plus authors, more than 200 participants participating from more than 20 plus organizations. We have received 50 plus papers, and out of those 50, we have selected 15 for final presentation. We are proud to announce that Mohammad Asaduzzaman Khan MP, Honorable Minister, Ministry of Home Affairs, has agreed to be the chief guest of this conference. The focus of the conference is advanced and sustainable technology for textiles, organized physically and also in digital platform. The major outcome that we expect from this conference is a national and international framework on how changing landscape in textile industry would shape the future and how as an academic we could lead that change. We are also very happy that our keynote speaker, Professor Dr. Bijoy Kumar Behera, Department of Textile and Fiber Engineering, Indian Institute of Technology, Delhi, who has tremendous background on academia and research, leading the Indian government's textile revolution. We would also like to announce that Engineer Mozaffar Hossain MP, Honorable Member of the Parliament, Jamalpur 5, Engineer Muhammad Masudur Rahman, President, Textile Engineering Division, IEB, will join as a special guest. We'd also like to thank our conference chair, Professor Muhammad Abul Kashem, Vice Chancellor, Bangladesh University of Textiles, and conference co-chair, Professor Dr. Shah Aluzzaman, Dean, Faculty of Textile Engineering, to be amongst us. Since its establishment in 2021, since its establishment in 1921 as an artisan school, BUTex has become a university in 2010. And the institute has produced extraordinary textile graduates who contributed textile sector tremendously. It is a great pleasure for me to stand this podium and acknowledging their contribution. We hope that this first ever international conference on textile science and engineering will add to that contribution. I would like to thank all the delegates and organizers and associations, the ministry, the university who have come from all around the country and the world. And we'd like to start our conference, but before that, আমরা সবাই শুরু করতে চাই আমাদের জাতীয় সঙ্গীত দিয়ে, এবং জাতীয় সঙ্গীত শুরু করার সময় সবাইকে আমি রিকোয়েস্ট করব হচ্ছে সবাই যেন দাঁড়িয়ে আমরা জাতীয় সঙ্গীতকে শ্রদ্ধা জানাই। শুধু দর্শক মণ্ডলী, জাতীয় সঙ্গীত। Um, we are going to start our welcome speech. Let me introduce ourselves as a host. I'm Dr. Abbasuddin Shayok, Head Department of Textile, Dyes and Chemical Engineering.
This is Dr. Kanis Farhana, Associate Professor and Head, Department of Apparel Engineering.
We'll take you throughout the session. Now I would actually ask Professor Dr. Hosnera Begum to deliver her opening speech. Let me introduce her. Professor Dr. Hosnera Begum is the head of Department of Engineering at BUTex. She has around 27 years of academic career, and her research area focuses mainly on jute along with other textile fibers such as cotton and also in textile testing. In her distinguished career, she has published many, taken various other administrative responsibilities such as Dean of the Faculty, Hall Provost, Project Director. She was also the first editor of Bangladesh Journal of Textile Science and Engineering, ICTSE. Ladies and gentlemen, let's welcome Professor Dr. Hosnera Begum.
যে খাটো ম্যাডাম আসবেনি লাইট লাগে চোখে ওকে চলবে হ্যাঁ ওকে এরকম দিয়ে রাখো চোখে লাগছে না অসুবিধা নেই চলবে চলবে হ্যাঁ ওকে 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 আসসালামু আলাইকুম গুড আফটারনুন চলবে চলবে লাগবে না টুডে ইজ এ ভেরি স্পেশাল ডে remarkable day for BUTex. We host our first international conference on textile science and engineering. On this remarkable day, it is a great honor to welcome all of you to the Bangladesh University premise. This is first ever conference to be held in our university. I wholeheartedly welcome all of you who are present here, and thank you for joining us today in this two-day international conference 2020. It is my pleasure to introduce our conference to all of you who have come who have come from different parts of our country, from different institute, from different university to share knowledge and their capacity, our perspective. There will be 5 sessions and 3 keynote speakers during the two-day conference. The conference will have more than 100 to 100 participants from different universities, make it truly a national conference in spirit. We are thrilled, really we are thrilled to have many experts in field gathered here to share their latest research, innovation and insight. This conference is an opportunity to explore the latest advance in textile, science and engineering, and to connect like-minded individuals who share their passion in textiles. We have an exciting program of keynote presentation and panel discussion that will cover a wide range of topics, including sustainable textile production, textile product development, and textile materials and engineering. We are particularly honored to host this conference in Bangladesh University of Textile for its excellence in textile education and research. This is a perfect opportunity to showcase this research and innovation in textile science and engineering that is happening in Bangladesh, and also to learn from the international experts we have. As we come together for this conference, we would like to remind everyone of this importance of respect and individuality. We ask them all attendants treat each other with kindness, courtesy, and respect, and to be open-minded, to be diverse perspective respected here. Let's make the most of opportunity to learn from one another, to network, and to collaborate. We wish you a productive and engaging conference, and we look forward to hearing our presentation and insight over these 2 days. Thank you for joining us. Thank you very much.
Thank you, Professor Dr. Hosnara Begum, for your welcome speech. Now, we'll move into our next technical session, which will be chaired by Professor Dr. Muhammad Ali. Let me introduce Professor Dr. Ali first. Professor Ali has more than 25 years of academic and industrial experience in short staple spinning, process and machinery, management information system, quality management of textile spinning mills. His area of focuses include fiber and yarn testing, theory and design of spinning machinery, productivity improvement, etc. He has been the head of the department and dean of the faculty. Currently, he is the director of the executive development program, which runs the postgraduate diploma program in textile industry management with the funding of ADB under a project with the Ministry of Finance. Now I'm requesting the session chair, Professor Dr. Muhammad Ali, and also session co-chair, Dr. Imdad, and also Dr. Sultan Ahmed to actually come into the stage. Thank you very much. Yes, sir. So our session chair is Professor Dr. Muhammad Ali, Dr. Muhammad Imdad Sarkar, and Dr. Sultan Mahmood. Now I'm requesting our chair to start the technical session with the presenter. You need a microphone for the session chair. We need a cordless microphone if possible to the session chair.
Hello. 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 Thank you, Dr. Abbas. Let's start the technical session. The first technical session will be held right now as a part of the conference. So thank you everyone for joining in this conference. I'd like to request Saima Sultana Urmi. Is she available here? Saima Sultana Urmi, Department of Textile Engineering Management. She is the presenting author of the first paper. The title of the first paper is A Study on Sustainable Disposal Behavior of Used Clothes and Motivational Factors Towards Such Behavior in Bangladesh. So I am requesting now Saima Sultana Urmi to present his paper.
Hello everyone. Thanks to all for being here today. First of all, I want to thank all of my honorable teachers and organizers for organizing this international conference for the first time in Bangladesh University of Textile. And I also want to thank for giving me an opportunity for presenting my work in this stage. And my name is Saima Sultana Urmi. I am recently graduated from Bangladesh University of Textile in Department of Textile Engineering Management. And I am presenting my research work, which title is A Study on Sustainable Disposal Behavior of Used Clothes and Motivational Factors Towards Such Behavior in Bangladesh. Actually, this is my final year project work, and this work is done by me with one of my other class fellow. And now I am going to my presentation. Before starting my presentation, I want to mention some questions like, when we dispose our clothes to the environment, do you think about the effect of the environment or the effect on future generation? or have you ever thought how we dispose our used clothes by using sustainable disposal ways or not? So in this study, I actually want to give the answer of this query. So in introduction part, I want to mention 5 topics. The first topic is fast fashion, which leads to the consumer to purchase more. Because fast fashion means inexpensive clothing that that produced rapidly by mass market retailers in response to the latest trend. So it is the cause which leads to consumer to purchase more. And another is pollution, and the reason behind this pollution is due to heavy disposal of textile waste. And another is used clothes, which mainly means the textile product which the owner no longer wants and decides to dispose of it. And the fourth is sustainable disposal of used clothes, which mainly means the disposal way of used clothes, focusing on socio-economic and environmental issues. And the fifth is motivational factors. Different motivation factors influences people's sustainable disposal behavior, like economic factor, social factor, environmental factor, product-related factor, convenience issues, etc. Different research already have been done on clothing disposal behavior, sustainable disposal behavior of used clothes, and motivational factors towards such behavior. Like previous research has shown, people tend to discard their clothing when they want to buy new fashion items, need to make a place in their closets, or are simply tired of the items. Even in earlier research, it also showed that clothing can be repaired, redesigned, or reused, or recycled, etc. And in different survey, it was also said that consumer disposal practices are frequently motivated by different issues like interpersonal issues or situational or product-related factors, etc. So after extensive analysis of background and literature review, we build up 4 objectives to research questions and hypotheses. Here is given our objectives. The first objective is to define sustainable disposal behavior of used clothes. The second is to find out whether people in Bangladesh use sustainable disposal ways or not. And the third is to find out which sustainable clothing disposal way people prefer most. And the fourth is to identify which factors motivates more on sustainable disposal behavior. And here is given our research questions. So one of our research questions is to give the answer of do consumers use sustainable disposal ways in disposing of their used clothes? And another is what factor motivates consumer more to discard their used clothes if they are disposing of sustainably. So after analysis of the literature review, we mainly consider 3 main dimensions of motivational factor. One is economic factor, another is environmental factor, and the third is social factor. And based on these 3 factors, we make 3 hypotheses. The first hypothesis is economic factor positively influences consumer towards the sustainable disposal of used clothes, and the second is environmental factors positively influences consumers towards such behavior, and the third is social factors positively influences consumers towards such behavior. Here is given the methodology by which we approaches to the analysis and the results of our survey. We use quantitative data collection method and also use 5-point Likert scale by which we making our questionnaire by using Google form, and also we use convenience sampling method. And for statistical analysis and hypothesis testing, we use 2 software. One is IBM SPSS, and the another is Microsoft Excel. So we want to show the results depends on based on personal characteristics of the participants, descriptive analysis of disposal waste of used clothes, demographic and disposal behavior, and respondents' motivation towards sustainable disposal of used clothes. So here is given the demographic characteristics of the respondents, mentioning the percentage of the respondents according to the gender, age, education level, designation, marital status, and monthly income. Actually, one of our objective was there to find out whether Bangladeshi people use sustainable disposal waste or not. For that objective, we give the descriptive analysis of disposal waste. And in disposal waste, we divide the disposal waste in two criteria. One is sustainable disposal waste and another is normal disposal waste. And in sustainable disposal waste, we keep a donation, hand over to family or friends. The third is give it away for recycle, which is mainly a recycling process. And the fourth is reuse in household work. And in normal disposal way, we kept throw away process. And in this analysis, we found that 96% people use sustainable disposal waste, whereas only 4% people use normal waste. But in 96% people, maximum people except students don't know about the sustainability clearly. They don't have enough knowledge about the sustainability. So we can say that unconsciously, maximum people in Bangladesh use sustainable waste in disposing of their used clothes. And also, we saw that 92% people use donation method, so most preferable sustainable disposal way is donation. Here is also given the respondents from different divisions of Bangladesh in mentioning the map, and also given the demographic and disposal behavior. Actually, in this demographic and disposal behavior, we want to show specifically which divisions people use which sustainable disposal waste more. For here is given the exploratory factor analysis, which is mainly done on the three motivational, from the data what we collected from the three motivational factors. And here is given the KMO and Bartlett test. And KMO and Bartlett test mainly done for analysis the suitability of the data for sampling method. And here KMO result is 0.648, which is in range, and the significance value of Bartlett test of sphericity is also in range because it is less than 0.05. So we can say that our data is suitable for factor analysis. Here is also given the model summary, ANOVA analysis, and regression analysis result. And after doing 3 analyses, we get the test result of hypothesis. And we saw that in coefficient or regression analysis result, beta value of environmental factor is 0.151 and economic factor 0.212 and social factor 0.140. So in case of environmental factor, we get the beta value is greater than 0 and also get the value of significance is less than 0.05. So our hypothesis 1 is accepted, and also in case of hypothesis 2 and hypothesis 3, we also get the beta value and significance value is in range. So we also say that hypothesis 2 and hypothesis 3 are also accepted. Here is also in discussion part, actually we want to explain our 4 objectives. Our first objective was to define sustainable disposal behavior. So here is given the definition of the sustainable disposal behavior. The sustainable disposal of used clothes refers to the disposal of used clothing focusing mainly on socio-economic and environmental issues. And the second objective, we found that unconsciously people in Bangladesh use sustainable disposal ways in disposing of their used clothes. And the third is people prefer donation process more because donation is an easy way in Bangladesh context to donate their used clothes to the poor people or their neighbor or to give it to their family member. So people prefer donation most. And among three motivational factors, economic factor has more influence on consumers than social and environmental factors, because we found that the beta value of economic factor has greater than other factors. In conclusion, here is given the summary of findings, limitation, recommendation, and future research. There were some limitation in our survey, like we did not do the disposal behavior of any specific group like the young generation or adult people or fashion conscious people or fast fashion buyers, etc. are discussed here separately. And we didn't give any strategy to promote sustainable disposal behavior, and we are not able to collect more data from other divisions except Dhaka, and we didn't take the burning issues. So here is some recommendation based on our survey. The first, we should try to export used clothes at a cheaper cost after reprocessing, and we also try to increase the recycle store and recycle business, and also we try to increase the knowledge about sustainability through mass market and advertising. So based on our recommendation, here is also given some future research opportunity. The first opportunity for research can be the to find out the way of the opportunity of reprocessing to export the used clothes, and the second is to find out the ways of increasing recycle stores and recycling business, and the third is to find out the advertising way to increase the knowledge about sustainability through mass media or social media, etc. in Bangladesh. So that's my overall presentation, and again, thanks to all. Any questions, sir?
Thank you very much, Saima Sultana Urmi, for presenting his paper. Now I would request from the audience, do you have any question? So if you have any question, please raise your hand. The microphone will go over there. So the title was the sustainable disposal behavior of used clothes and motivational factors. So the theme was how to use used clothes. Please.
Could you please open the slide?
Could you please go show your slides, please?
And ANOVA model, I want to interested to know something about ANOVA model. How we study this model, ANOVA?
Yes.
ANOVA.
Could you please explain? I want to see the slide as well.
Sure.
So you would like to know the ANOVA analysis?
Yes.
Okay, please.
Okay. In ANOVA test, actually we want to show our independent factors have any effect on the dependent factors. Actually, we found out that. And in that case, in ANOVA test, the significance value is in range because the significance value should be less than 0.05. And we found the significance value is 0.00, which is less than 0.05. So we can say that the independent factors, social factors, economic factors, and environmental factors have impact on dependent variables like sustainable disposal behavior. So our intention to analyze this ANOVA is that.
So thank you so much.
So thank you very much. Actually, we have time limitation. That's why we are not accepting any further questions. So thank you very much, Saima Sultana Urmi. Now we are moving to the second papers. So the presenting author is MD Ghulam Sarwar Raihan. So he is the lecturer of Bangladesh University of Textiles, Department of Textile Engineering Management. The title of the paper is Global Value Addition of Bangladesh Textile Clothing Industries Export, a Sub-Sectoral Analysis. So now I request MD Golam sir or Raihan to present his paper.
Just taking 1 minute from the chair, I'm requesting IT support service to come over here and make sure this presentation here and the screen is synchronized. A quick IT service. Should I check if it is working or not? What's the name? No, don't go for it. Service. Okay. You are trying to fix it from there, right? Okay.
Technically, আসতেছে না কেন এটা? এখন আসছে। টাইমটা তো আসলে করা দরকার আসলে। টেকনিক্যালি এগুলো আসলে যেভাবে চলতেছিল ওইভাবে চললেই তো হতো।
Assalamu alaikum. Very good afternoon to everyone. At my final presentation, I would like to appreciate the organizing and technical committee of the first international conference on textile science and engineering in BUTex premises. It's my great pleasure to present my recent article in this conference. Thanks to the technical committee for providing me that chance. I'd also like to thank the keynote speaker, Professor Dr. Bijoy Kumar Behera, and the technical session chair, Dr. Muhammad Ali, Dr. Endra Sarkar and Dr. Sultan Mahmud sir. I am also grateful to Professor Dr. Mahmud Masoom for supervising me in this project. This research project has been funded by BUTex Research Grant 2021-22. Okay. The title of our presentation is Global Value Addition of Bangladesh Textile Industry Export, a Subsectoral Analysis. As we know, textile clothing industry in Bangladesh is it's not an upgrowing sector, it's a growing sector. Okay, in this article in our presentation, the TCI industry elevated as textile clothing industry in Bangladesh. TCI industry of Bangladesh is a great contributor to the gross domestic product share, almost 84%, capturing and employing almost 44.4 million people, with the women empowerment of 80%, earning 83% of foreign currency, along with all the social and economic development in Bangladesh. The revolutionary growth of TCI industry in Bangladesh has been elevated after 1980s, becoming more labor-intensive industrial sector because of the cheap labor cost. With rapid TCI growing, Bangladesh GDP has been elevated from 6.29 billion USD in 1972 to the 286 billion by 2021. Okay, as of fiscal year 2021, textile clothing industry of Bangladesh has uplifted to USD 42 billion USD, and now the target for the 50 billion within 2030. Okay, if we look through the backward linkage industries for the TCA industry, we get that the basic materials fiber that comes from the either from chemical industry as man-made fiber or the local source, the cotton fiber, have to pass through 5 successive processes. After all, we get the finished product as the garments. As first, if you look to the spinning section, that's the fiber from yarn forming. And after that, the weaving or knitting, that's the fabric from turning. After the fabric coloration process, as like printing, dyeing, screen printing, dyeing, or all over printing. After all that, along with the other trims and accessories, our final goods, finished garments has come. Okay, if we look through the spinning section, we have to go through analysis that our basic materials, fiber, that we don't have this. We have to import almost all the fibers from outer world. After that, we have some yarn facility. The most neat composite garments have their own yarn facility. They can meet up their own demand. But in case of oven sector, oven garments they don't have the oven section. So they have to import all the oven fabric from outer world. In case of fabric coloration process, the weight processing, all the dye step and chemicals we have to import from outer world. Some of our chemical companies are producing some chemicals for our dyeing sector. And the trimming section, in the trimming section, our locally set up trimming factories from last decade, they are producing some quality trims accessories, but for critical items as the zipper, polybag, we have to import from outer world. So beside the high export figure, we are earning more and more export currency. We are lagging behind in our backward linkages for import materials. Our research question is 2 types. How much is domestic value added embodied in textile clothing industry Bangladesh? How much we are adding domestically, value addition, and how much we are adding for foreign source. For this research project, we have performed a methodology from Koopman, Wang and Wei 2014. There, the gross export has been divided 3 broad terms. There's a value addition export that's like from domestic value added. After that, domestic value added in intermediate products that already return, again return home. And finally, the third term is the foreign value added. That's we export, but with the help of foreign materials. Okay, the first term is also divided into 3 parts. Number 1, domestic value added in direct final goods export. Actually, we are adding domestical value that we finally export that. And the second one, intermediate products, as like in fabric form or other form that we value domestically, but we directly export that. Then the third term, our main important focus, foreign value added. Here, the number 7, foreign value added means we directly export the goods we are adding from foreign source, and the intermediate from a foreign source. This is the proposed framework for our analysis. This framework is also available in this methodology. Okay, for this methodology, we have performed MATLAB analysis because for the analysis, we need the MRIOT, multi-regional input-output table. But this table is not available in ADB database, Asian Development Bank. So we have to compile the database from the ADB and UNCTAD, United Nations Conference on Trade and Development. After analysis, we have a picture of the broad category according to gross exports. There, if we look through some point, number 1, DVA in final goods export. That was in 2021, 65%. That's elevated to a value of 71% and keep the constant progress in 71%. But in case of foreign value addition, that was 2001 at 13%. That is lower to some small value 11% and again 10%, but not too much lower. Okay, our main focus was the sub-sector analysis, not on the overall. If you look through a intermediate export and import from our country to the other continents, we look through the Asia, Europe, and North America are the prominent in both intermediate export and import. Okay, for intermediate import, we are lagging behind, right? Intermediate export, you are good. Okay, total finished goods export import. We actually we are producing for export products, so we import less. Okay, but in Asia, Europe, and North America, we are continuously growing in our export business with our made in Bangladesh label. But here one matter is to focus that in 2019, the export volume was 32 billion. In that year, the input into intermediate product was 15 billion. That means half of the product we are exporting 32 billion. But we are lagging behind 15 billion in our intermediate product from import. When we move to the fiber production at the first subsector ours, in that case, we found that domestically value added is too poor, right? 10% to the 1, then 11%, then 19, just 6%. But for foreign value, we are adding 79 to lower was 72%, then again about 75%. So if you do the 19 picture, India, US, and Brazil was the most prominent supplier for our fiber production. That's the 28.8% for India, and USA 20.5%, and Brazil 16.2%. For yarn manufacturing, in that case, we also lagging behind, but for our local yarn suppliers, we are moving step forward. Okay, to the 61%, then lower to 79%, 11, and then simple affiliate 19, 74%. In that, 2019, India 62.7%, we have import from India, and we have import yarn from China 18.4%. Okay, we have some yarn supplier, just because of our yarn supplier high price, they are claiming upcharge because local yarn cotton price increasing day by day. Then in case of fabric manufacturing, in the fabric, the foreign value addition was 44% of the 1, but lower to 11, 27%. Again to the 19, uplifted 35%, because our local fabric manufacturing facility is too poor. For knit garments, most composite factories are producing their own knit fabric, but for woven garments, they have to move for import. If you look the picture, in China, Chinese type in Hong Kong, there are some cheapest fabric available for garments export. So in case, so instead of the local producer, Bangladeshi garments manufacturer move for the import. Okay, for dyes and chemicals manufacturing, to the 1, because we can't produce any dyes types, we just produce some chemicals. In that case, to the 1, Bangladesh expend over 1.1 million USD for dyes and chemical import. Then 11, 19.9, then continuously upgrowing 19, 152 million USD just for dyes type import. Then for trims and accessories, some locally producing trims and accessories are good in quality, but for critical, as we mentioned earlier, but for critical in trims, Bangladesh can't afford that. So after this subject analysis, we can, instead of we earning the highest figure, large figure, day by day, we are increasing in our export, but we are lagging behind in our import also. So the large portion we are sharing with our outer world. So some limitation here exists because we have analyzed only the sector analysis, but the product is specific. Which product are we lagging behind especially, or country specific? We are also looking forward to research this. Okay, thanks so much.
So thank you, MD Ghulam Sarwar Raihan, for presenting your paper. Now I would like to request from the audience to ask some questions, if you have. So any question? So I have one question.
Sir.
So you have studied actually value addition of Bangladesh textile and clothing industries.
Yes, sir.
So is it possible to analyze as per sector-wise, like contribution of the spinning industry, contribution of the weaving industry?
Okay, sir.
As a part of the value addition. So which sector is dominating as a part of the value addition?
Sir, you mean some comparison?
Yeah.
Okay, it's possible. It's possible to do. Because in this project, we just go through the sectoral, sub-sector, spinning for the situation, for knitting for situation, but it's also possible to compare among all the sectors.
So our spinning industry is adding value to the...
A little much, sir. Little much, because with the upgrowing clothing order, we cannot meet up the growing demand.
Okay. So thank you so much for your presentation.
Thank you, sir. Thank you all. Assalamu alaikum.
So our next presenter is Fahmida Faiza Fahmi, Assistant Professor, Prime Asia University. So her paper title is Comparative Analysis between Bangladesh's locally produced potato starch with commercially used one, short sizing materials in terms of technical feasibility. So Fahmida Faiza Fahmi, I'm requesting you to present your paper. So this paper is basically a comparative study between locally produced starch, sizing materials with a commercial one. Please.
Assalamu alaikum. Thank you for giving me this prestigious opportunity. This is Fahmida Faiza Fahmi. The title of my presentation is Comparative Analysis of Bangladesh's locally produced potato starch with commercially available one-shot based sizing material in terms of the technical feasibility. Along with me, my co-authors are Mrs. Shilpi Akhtar and Mr. Mohammad Saiduzzaman. Let's start the presentation with a story of Mr. Azhar Ali, who is a potato farmer of Dinajpur. In 2022, he landed potato in his 5 bighas of land. And after that, he found out a lot of production, but he stored his residual potatoes in the cold storage for getting the better profit. But the irony of fate is, during the end of the season, the price of potatoes fall down and it became taka 6 per kg approximately. And this is not the scenario of this year only. From last 5 to 6 years, Bangladesh is facing the same problem. If we look down the annual demand and annual production of Bangladesh in the sector of potato, in every year, Bangladesh is having the surplus of around 3 or 3.1 million ton, and this surplus amount potatoes become wastage in most of the cases. So finding out an alternative of these potatoes is important to assess to overcome the loss of Bangladesh. So as we know, potato is a carbohydrate based product, so the main content of potato is starch. So we can use this starch in the weaving industry as a sizing material to use this residual amount of potato. The objective of my study is extraction of potato starch from this surplus amount of potato and surplus amount of potato so that the country can get benefit by using it in the weaving industry. Then assessing the technical properties of this potato starch, size cotton yarn. After that, comparison of the technical performance of potato starch as a sizing material with commercial one-shot based sizing agent. And finally, analysis the economic feasibility and affordability of potato starch as a sizing material. In my project, I have used 100% cotton yarn of 20 English count to assess the performance. Then I sized the yarn with both potato starch and commercial one-shot based sizing material, which is Amatrolid 8923, and evaluate the performance factor by specific tests like tensile test, elongation test, abrasion resistance, hairiness test, and test of yarn count before and after sizing. To start the project, at first I have to extract the potato starch. I have to extract the potato starch from the local potatoes. Okay. So for extracting the potato starch, initially I have to crush the potatoes, then I have to wash it with a continuous water flow. After that, I have to reserve the wash water in a storage. If we keep it for few hours, then the starch is precipitated in the bottom of the wash water, then we can separate it and dry it by air dryer or sun heat drying. In fact, we can use the residual potato in the food industry, especially in the chips industry, and as it is removed of starch, so it is more healthier than the conventional potato. Here are the sizing recipe I have used to complete the process. In potato starch sizing, we need some additional elements like vegetable fat as a softener, an antiseptic as it is a natural material, so I use copper sulfate, and a wetting agent in which I use china clay. In terms of one shot, as it is a mixture of all necessary ingredients, so I didn't need any other thing except water. Okay, here is the process flow of sizing. After size material cooking, then I size and dried the yarn, then I feed the yarn into the weaving loom, and after that weaving is done. Okay. If I show the general property, both of the potato starch and commercial amatrolid is white in color. Both are used in the powder form, and the both sizing agent have no distinctive order. Then I analyze the tensile strength, which is one of the most important factor of a sized yarn. After effective sizing, the tensile strength of yarn should be increased, because sizing is a procedure of incrementing the tensile strength of yarn. So in my case, after sizing the yarn with both potato and one shot, the tensile strength was increased significantly, but one shot showed a quite slightly better performance than the potato starch. If I consider the elongation of fiber yarn usually occurs due to the slippage of fiber between the yarn. So after sizing, the gap between the fiber reduces, so the elongation percentage also reduces. In case of unsized yarn, the elongation percentage is quite impressive, which is 6.796%, but after sizing, it reduced into 5.276% for potato starch and 5.192% for the one-shot sizing material. That means in this case, both of are going similar, but potato have quite a slight improvement. Abrasion resistance. This is one of the most important factor of a sized yarn, because the main concept of doing sizing is increasing its performance on the weaving loom. So if we want to increase its performance on the weaving loom, we need greater abrasion. That means the yarn should be break lately. In case of potato starch sized yarn, the abrasion increased tremendously, and it can handle 201.6 cycles before breakage, a single yarn. In case of one shot, it was 182 cycle. Adequate size take-up percentage is also an important factor for effective sizing. If the size take-up percentage is more, in that case the yarn become stiffer and it become difficult for desizing. On the other hand, if the size take-up percentage is lower, in that case the breaking become more frequent. So in case of doing sizing with maintaining the earlier recipe, the size take-up percentage for potato starch sized yarn was 11.36%. On the other hand, the one-shot sized yarn was 11.68%. Reduction of yarn hairiness. In both cases, the sized yarn showed tremendous reduction in the yarn hairiness, by which the yarn breakage rate decreased. In this case, also potato starch shows better yarn hairiness reduction compared to the one-shot sizing agent. Reduction of yarn count. As sizing provides an additional coating into the fiber surface, so the yarn count increases. In both of the cases, sized yarn shows better increment in the yarn count, while potato starch reduces the yarn count slightly more than the commercial one-shot. Okay, if I sum up the technical properties or technical characteristics, both of the material is going simultaneously almost, but the economic affordability is one of the major things by which you can decide to adapt a new product by leaving a already marketly sustainable product. So let's see the economic affordability of the potato starch. After extracting 1 kg of potato, I got almost 233 gram of potato starch. So to get 1 kg of potato starch, I need almost 4.29 kg of potato. So if I can sum up the process, as it is a simplified process, approximate 1 ton of potato starch can be made in an 8-hour shift in commercial scale. So if I sum up the raw material cost, manpower cost, electricity and utility cost, transportation cost, and some fixed cost related to machine and land, the total cost of producing per shift, per ton of potato starch, which I can produce in a shift, can be 58,880 taka. So the cost of per kg potato starch will be 58.88 taka. So if I think a 10% of profit margin, then the cost of the selling price will be 64.76 taka per kg. In the previous slide, I just showed the cost of potato starch. But in this slide, as potato starch needs some other materials to complete the sizing process, I have shown out to the total cost of making a size solution by using potato as well as commercial amytrolide. In potato starch based size solution, I need I need 100 gram of potato starch to make a 1000 ml of size solution, which can cost 6.476 taka if the selling price was 64.76 taka. The vegetable fat required was 10 gram, which cost 2 taka. The antiseptic, which is copper sulfate, required is 3 gram, which can cost 4.5 taka. And the wetting agent, which is China clay, which need is 15 gram, this can cost 5.25 taka. The total cost of making 100 ml of size solution by potato starch is almost 18.226 taka. As the commercial electrolyte is quite lighter in adhesive property compared to the potato starch, so it needs more amount to produce the same amount of size solution. To produce 100 ml of 1000 ml of size solution, 200 gram of electrolyte is required, which can cost 50 taka, as the cost of electrolyte or one-shot sizing material is varied among 250 to 280 taka. So the one shot I bought from the market was 250 taka per kg. There have a lot of future research scope. One of the limitation of my work is I have evaluated the performance of sizing by evaluating only one type of yarn. So as this was a self-funded project, so I could not assess with so much variations. In future, the sizing performance can be evaluated by using a lot of variation. The weaving efficiency for different structure can also be assessed. To call potato starch as a completely sustainable product, it should be tested the feasibility by according to the effective frameworks like RWW, risk matrix, and so on. That's all my project. Thank you for your concentration. If you have any question, then feel free to ask.
Yes, thank you very much. So any question, please? Yes, one question. Please. So I have one question to you. So what is the actual weaving efficiency, or that is loom efficiency?
The loom RPM was 40 and the PPI of the weft insertion was 50.
Yes. Hello, so thank you so much for your nice presentation. I have actually two questions, very shortly. First one is that what was the test methodology you have used to test the abrasion resistance of yarn? And the second one is, since there will be desizing, how it could improve the hairiness of the yarn?
I could not listen the second question.
The second question is how you have evaluated, because it's a sizing, and after that there is a desizing, and how it could impact the hairiness of the yarn.
Okay, as the size, now first I should answer your first question. To evaluate the weaving efficiency,
No, the abrasion resistance of yarn.
To assess the abrasion resistance of yarn, I have done it. I have gone through the CCI weaving sample making loom, and then I computerizedly set the PPI into 40, and then machine RPM into PPI into 50 and machine RPM into 40. Then I just calculate the number of cycle it has gone through, and then I analyzed it, as it is a digital machine by this. And your question is about desizing process. As the size take-up percentages of potatoes is quite equal or similar than the commercial sizing agent. In fact, it is quite lower and give actually equal performance. So after the desizing process, it didn't take any more harsh desizing compared to the commercial one. So after the desizing process, I think it didn't have any adverse effect. I didn't do the desizing process till now, but in future I will definitely do it. Thank you.
So any other question?
My name is Dr. Furkan. I think you've done a very good job, for particularly with proposing sustainable materials for textile processing.
Thank you.
But I have some question regarding your analysis, particularly the mechanical properties. For processing yarn or promoting yarn in the industry, it's very important to how the materials are retaining the structural integrity. So you analyze the breaking force, only the breaking force which is recommending the strength of the materials. But what is actually ultimately, you cannot recommend that the breaking force can ultimately give you the strength.
Okay.
Do you understand my point? So you only define the breaking force, whereas the tenacity of the material and also the toughness of the material is very important. So what do you say about these two queries? Thank you very much.
Okay, as I said earlier, I have some limitations in my work as it is a completely self-funded project. So in future, I have a lot to do with this work. In fact, I have planning to do it with a lot of things in this about this work. So I will definitely find out the tenacity and other parameters.
Yeah,
and we'll come
this
up
was
with
the
a
beginning of the work,
complete
so
conclusion.
maybe in future she will do more work on it. So thank you so much. This technical session is over. Thank you so much.
Assalamu alaikum. I have a question.
Actually, we are running out of the time, so we are not accepting any question right now. Sorry about that.
Thank you, the session chairs and co-chairs, for moderating the session. It was an excellent work, and I would congratulate the speakers. And thank you. Maybe the next time we'll take the question. So, yeah. Now I'm requesting the session chairs to take. Our next, so the session chairs are working on their part. Our next session will be from our keynote speaker, who is we are waiting for. He is a professor of IIT Delhi. Let me introduce him first. Dr. B.K. Behera is working as a professor in the Department of Textile and Fiber Engineering at IIT Delhi. His area of specialization includes fabric manufacturing, 3D weaving, braiding, fabric hand, auxetic textiles, textile structural composites, and concretes, mechanics of textile structure. His current research interest includes design and manufacturing of textile structural composites and concretes, green composites, 3D weaving, auxetic weaving and composites, and protective clothing. Professor Behera has authored more than 320 peer-reviewed papers and delivered more than 350 talks in various international conferences and symposia, including 70 plenary and invited speech and international conferences. He has authored, co-authored, and chapter contributions 15 books relating to textile structural mechanics, soft computing in textiles and weaving technology. Professor Behera has supervised more than 120 PhD students and master's students. He has 8 patents to his credit. Professor Behera has successfully completed 30 sponsored research projects and more than 75 industrial consultancy projects as principal investigator. At present, he is heading a focus incubation center in 3D weaving and structural composites supported by Ministry of Textiles, Government of India. He has also worked as visiting professor in Shinshu University, Japan, Technical University Liberec, Czech Republic, University of Sao Paulo, Brazil, Uzak University, Turkey. He has been an invited speaker in many foreign universities and institutions, which includes Shinshu University, Japan, Technical University Liberec, BUTex Research Center, Czech Republic, Promatec Machinery Research Center, Italy, Composite Research Institute, Budapest, Sao Paulo University, Brazil. Professor Behera is a member of Governing Council of several reputed textile institutions and member of Board of Studies in 5 technical universities. Professor Behera has a very strong interaction with several reputed textile industries in India in the capacity of a consultant. He is also a member of board of directors of 3 reputed textile companies in India. With all these accolades, let's welcome Professor B.K. Behera for his keynote speech. you have your water here, and then you have your from here you can do that. Yes. So you have 45 minutes. 45 minutes, not 1 hour. 45 to 1 hour, because I will take some more questions. Yeah. Okay. Thank you.
Good afternoon. It's my pleasure to deliver this lecture. Is mic is working?
Maybe use that mic because that would be easier, or you can use that mic as well. Which one is preferred?
It's okay. It's my pleasure to deliver this lecture on advanced composite materials. In fact, I feel honored to share my thoughts in this first international conference organized by BUTex. I would like to thank the Vice Chancellor, Professor Abdul Qasim, and Dean, Professor Saha Limudzam, and also the faculty members of the textile department of the universities. So the agenda of this presentation will go like this. First, I would like to give some idea about the global composite industry. Then some information of advanced materials, then advanced textile structure for composite materials, and some examples on auxetic materials, blast resistance composites, textile structural power composite, and then I'll give my conclusion on the subject. If you look at this data, the composite material market is around 42.2 billion in 2023. One thing we should understand, composite is not a finished product, it's an intermediate material. We use textile fiber and some matrix material to make the composite, and composite as an intermediate material which is used to different finished product. So composite as such is an intermediate material, it's not a product. And there is a very positive forecast for this material, which may touch about $163 billion in 2030. Why this growth? There are several reasons why this industry is growing rapidly. The first is the increasing demand for lightweight materials. Everywhere we want to make our material lightweight, particularly in aerospace, drone, defense, automotive industries, marine, and so on. Wherever there is a fuel consumption, we want to reduce the mass. The second driving force is wherever we feel corrosion and chemical resistance requirement is very, very high, particularly in construction. glass is the main fiber. In the world, almost 80% of the composites are made from glass fibers. Of late, natural fibers are also being used. That's why the scope of increasing composite business in Asian countries is more, because most of the Asian countries, because of its climatic advantage, we have a lot of non-conventional natural fibers apart from cotton. So these materials can be used as a major reinforcing product for composite making. Then some of the resins, these are the chemicals available everywhere, and to make more valuable composites, we use some fillers or nanomaterials as additives. So the emerging trend which really influencing this industry is development of low-cost carbon fiber. Carbon is one of the very important fiber to make most of the high value-added composite materials like aerospace. And carbon is a very, very expensive fiber. Many companies now are trying to develop low-cost carbon fiber which can be used for this purpose, and also high-performance glass fibers. There is one of the constraint in composite manufacturing, because conventional resin takes a lot of time to cure. So people are now trying to develop some resins which can be cured quickly. That will enhance the productivity. And in last 10 years, additive manufacturing, which is otherwise called in the market 3D printing, is found to be one of the very attractive method of making many composite materials which are complex in their structure and cost-effective method. And also the last one is multifunctional material, which I will give you some idea towards end of my this presentation. So potential countries in this are North America, Europe, and Asia Pacific zones. These are some of the companies all over the world who are leading manufacturer of composite materials. So this is some of the background information about composite industry. Let us talk about the subject, advanced materials. So what is advanced materials? Engineers know more than 50,000 materials. We broadly classify these materials into 4 groups: metals, polymers, ceramics, and composites. If you classify the materials based on their mechanical performance, we may classify to them like elastic, plastic, viscoelastic, or viscoplastic. Even you can classify the materials based on their applications, like construction materials, art and painting materials, textile materials, and so on. These are conventional classification of the materials. But what about advanced materials? Nowadays, a lot of research have been carried out to develop advanced materials, for example, biomaterials, nano-engineered materials, auxetic materials, and smart materials. These are materials which are highly value-added and can be used for very crucial purposes. We will see some of the applications in subsequent slides. If you look at advanced textile structural composite material, which is my subject, you will find a lot of research has been carried out in last decade to find out or to develop advanced structural composite materials, which includes various kinds of textile complex structures like 3D fabrics, spacer fabric, or auxetic composite materials, blast resistance materials, structural power composite, smart composite materials, and so on. Those materials or composites are used in automotives, aircrafts, aerospace, marine, and medical, sports, and also in health services. Coming to advanced textile structures for composites. So what are those textile structures which is used to make advanced composites? In our center, we develop variety of 3D fabrics. I'll give you, because it's a short presentation, example of about 5-6 different structures which are being, we are developing in our center. You can see these pictures which are developed in our center. We classify them as 3D solid structures, 3D hollow structures, 3D honeycomb structures, or 3D auxetic fabrics, or 3D profile structures, and 3D radome structures. So you can make out some idea how these structures look like, and subsequently we'll see what are the special mechanical performance of these materials. Let us consider first 3D solid structures. So these are basically multi-layer integrated 3D solid fabrics which are subsequently converted to composite materials or may be used for different protective applications. The specialty of these material is they are thick, they are load bearing. The delamination resistance of these fabric and their composites is very, very high when they are subjected to impact force or when they are subjected to ablation. And the most important one is the impact energy absorption capability of these materials is too very, very high. One can develop a wide variety of such structures by simply weaving manipulation. I will show some examples. You can see here, these are various solid structures in which you can play with weave design. The weave design which you see on the first layer of the fabric, the same design can be maintained in every layer. It could be 3 layer, 4 layer, 5 layer, 10 layer, depending on the capability of your weaving machine. So I am not going through how they are manufactured. Tomorrow I will present in briefly what are the machines used and how these structures are produced briefly in tomorrow lecture. But these are the structures we have produced and they can be used for structural composite material. I'll just give you only one property. Suppose, why do we want to develop these fabrics with a different weave design? As I said, one of the most important requirement of this structure is, or potential of this structure is, high impact resistance. So, if you manipulate weave design is nothing but the number of interlacement per unit area. So, when we produce fabric of these different weave designs and measure their energy absorption capacity, you will find the energy absorption capacities are different. And how they vary. What is the basic fundamental relationship between energy absorption capacity and weave design? What we have observed from our research, as you go on increasing number of crossover points per unit area by simply changing weave design, convert those fabrics into composite materials, their impact energy absorption increases exponentially. So this is just one result. And we have several findings with respect to other mechanical properties which may take longer time. If you want to engineer this product, we can go for modeling. So we have a strong modeling team where we try to find out producing fabrics of 3D structures, different layers, different fibers, different thickness, different fiber volume fraction, and we try to see what is the impact energy absorption. By modeling, the question is, if you model, then you can see in which structure allows more penetration of the bullet, which structure allows comparatively less penetration of the bullet. You can also quantitatively determine how much it penetrates and how much is the impact energy absorption. This is possible if you plot a curve between bullet pre-impact velocity vis-a-vis bullet post-impact velocity, which you can measure during this simulation process. During simulation, if you give as input parameter of all the structural parameters, including fiber modulus, then you can assess what is the velocity of the bullet before it penetrates through the structure and what will be the velocity of the bullet once the bullet passes through the structure, and plot a curve. You can see if the curve tilts towards strain axis or x axis, obviously the penetration resistance is less. If the curve tilts towards y axis, the resistance is more. This helps to develop how to develop a 3D structure in which the impact resistance is high or less. This is briefly about 3D solid structure. let us talk about another structure which is very popular in our lab. We have a lot of project on 3D woven honeycomb structures. You know what is honeycomb? Honeycomb is a popular material, particularly in sandwich making industries. Honeycomb is well known for its energy absorption capacity, particularly impact energy absorption capacity. If you analyze the structure of the honeycomb, it's a hexagonal structure. In 3D, what we do, you can change all these parameters you see here. Its bonded wall length, its free wall length, its opening angle, number of layers, and height of the honeycomb cell. And if you go on changing these construction parameters of the honeycomb, you can change its impact energy capacity. So, using this principle, we use different honeycomb structures and try to evaluate them. These structures or these composite materials are popularly used mainly in high strength, in what is called sandwich panels, lightweight sandwich panels in aerospace industries, railway, marine, and in making aircraft body parts. It is also used for thermal management because it is hollow structure. It is used for packaging sector, and it absorbs energy. It can withstand shock and vibration. That's the specialty of this structure which are being used. So how do we characterize once we develop this structure? The basic principle to characterize honeycomb structure is to simply plot a curve between load and deformation. Look at this curve. This is a load deformation. So this load means it is a compressive load. It's not tensile load. Because honeycomb is well known for impact, for compression. When you try to characterize the honeycomb structure, you will see this curve has a distinct three zone: elastic zone, a plateau region, and a densification region. And adjacent to the curve, I have shown the honeycomb structure where I have already explained what are different parameters. You go on manipulating with these parameters, you can change the shape of the curve. While engineering this fabric or composite, our aim is to enhance the plateau zone length. That means, what is this plateau region is? Larger is this plateau region, higher is the energy absorption capacity of the honeycomb. This is the basic principle which helps us to develop a honeycomb having higher energy capability. Now proceed further, let us see another 3D structure, which is a profile structure. This is comparatively complex weaving. You can produce, these are all samples which you see here developed in our lab. You can produce L shape, U shape, H shape, pi shape, plus shape, any shape you want. These structures are mainly used for making machine components, and they are converted to composite materials. So I'll just show you similarly only one example from where you can make out how it is being used. Let us see these T components, which is used in many machine parts. We want to substitute these T components by a textile structural component. So we try to develop or weave this fabric by weaving on a 3D jacquard weaving machine, and the fabric produced looks like this. This fabric is converted to composite material, and look at its junction. The specialty of this composite is, if you look at its metallic counterpart, the junction is very, very heavy. Have a joint, have a stitch, have a bolt. The joint is weak and it is heavyweight. If you want to develop a machine component having clean, lightweight junction with high strength, then this profiled woven structure composite material is the right answer. This is how we develop this fabric, convert to composite materials, and try to assess its properties. And we try to measure the special parameter of this composite, which is called junction strength. So junction strength of the original fabric structure, which is used to make this, then junction strength of the integrated structure, that is this composite material, and equivalent junction strength of a stitched composite materials. If you stitch it, if you don't produce it from a 3D profile structure, then you can see the clear difference in these three. Definitely, the integrated 3D profile structure gives higher junction strength than the stitched one. That's the benefit why we develop this structure and use for different composite components. However, it is not that easy. Weaving of this structure is very, very complex. Maybe I will discuss this again in tomorrow, how we go for weaving, what is the complexity. But from this diagram itself, you can make out. Look at, this is a 3D profile structure. We are trying to make a L shape. So look at the joint. While weaving, the peak density at the joint where the side bends becomes less. So if the peak density is lesser, then that joint becomes weak. So the challenge is how to maintain peak density even when the side or direction changes at the junction point. If you know how to do this by weaving manipulation, then you can produce very high value added composite profile structures. Now, let us proceed further. Let us discuss first auxetic composites. Auxetic is a very, very, you can say, most interesting material today in engineering. Now, textile people are also developing auxetic materials. So first let us understand what is auxetic materials. These are the materials which gives negative Poisson's ratio. Means when you extend this material in one direction, it also expands in transverse direction. Normally, for a conventional material, if you are expanding in one direction, it contracts in other direction. In this case, it is opposite. You try to expand in any direction, you will find it will expand in reverse direction. Same thing happens even if you compress it. If you compress in x-axis, you will see it gets compressed in y-axis also. So question is, why it happens? How it happens? What is magic there? So we try to understand the mechanics of this geometry of these materials. Then we try to develop how to weave this geometry in textile. As you know, textile people are very, very smart people. Weave design, I think you must be aware of, the computer science or the IT industry which is ruling today all over the world came from textile people. In our jacquard design, it is simply selection or no selection. That means the binary number system, 0, 1, 0, 1. That is what we do in our jacquard. And simply selecting the interlacement order, we can change the mechanics of whole fabric. That is what we do in simply weaving, changing weave design. You look at only strength or extension. We have never given a thought, even changing this weave design, changing the float length, changing the interlacement order, we can also change the Poisson's ratio of the material, and which can be used for many engineering applications. So we have made our research to understand what is the auxetic geometry. In general engineering, it's not only textile. What I am now showing in this slide, it is for general mathematics. All the geometries can broadly be divided into 4 types. Reentrant structure, foldable structure, rotating structure, and chiral structure. In all these structures, when these structures will be subjected to a deformation, you will find they are exhibiting negative Poisson's ratio. I will prove you, only show you one or two which you can do with any geometry you are looking in these slides. Let us consider first only one geometry. Let it be rotating square. So just take unit cell of this rotating square. The unit cell of this square can be represented by this. You simply give some dimension or symbol to each side. We define theta as the angle of bend here in this diagram, and L is the side of the square. So you can find out what will be the value of x, which is L into cos theta plus sin theta. You can find out the vertical length y, which is L into cos theta plus sin theta. Then we try to strain it. When we'll deform it, y will change to y plus del, x will change to x plus del x. You try to find out what will be del y and del x. And we know what is Poisson's ratio, that is lateral strain over longitudinal strain. Strain means simply del L over L. And using basic principle of physics, you calculate the Poisson's ratio, in this case is coming -1. So this is the beauty of this particular geometry, which when stretched or deformed gives negative Poisson's ratio. And this specialty is used for many, many wonderful applications, particularly in textiles. We try to develop this principle to make a different weave design from a rotating square. You can see these are the different structures we have considered, and we have developed fabric out of them. Then converted these fabrics into composite materials using the same process. Of course, I have not discussed, I think you must be aware, composite can be produced from a textile reinforced bed by different processes. You can take a VRTM process to convert this fabric into composites, and you can measure its Poisson's ratio. The measurement of Poisson's ratio is very, very simple. Take the fabric or composite on any UTM, mark 4 points, 2 points in x-axis, 2 points in y-axis before the fabric or composite is deformed. Then after deformation, look at what is the change of position of these 4 points taking place. Then you calculate the del x over del y, lateral strain over longitudinal strain, which will be Poisson's ratio. This technique is used to find out the Poisson's ratio, and all the geometry which I have shown you, we developed fabric from those geometries. Then we try to develop the fabric and composite. This is first the result of the composite. Look at these, all these plots are between strain over Poisson's ratio. So look at the curve has gone to the negative side. Everywhere the strain is in the negative. This is how we get negative Poisson's ratio. Only thing is, different structures give different Poisson's ratio. Depending on the requirement of your application, where you want -0.2 or -0.3 or -0.5. Normally for most of the materials, these negative Poisson's ratio is between 0 to -1. But nowadays, special structures are being developed where this Poisson's ratio value can go as high as -5, -6 also, literature report. But in textiles, we have been really able to produce some of the textile structures, particularly here it is shown at the bottom, which is a random structure. The Poisson's ratio is -0.54. That is the highest one. And we convert this fabric into composite materials. Then we use the same principle to measure its Poisson's ratio and plot the Poisson's ratio, and you can see here even the composite also gives negative Poisson's ratio, but not to that extent as the fabric gives. The exoticity of composite little bit reduces, which is obvious, because when a fabric which has its inherent extensibility behavior embedded with a resin, then in a woven fabric the interlacement points are not welded points, but when a resin impregnates through the fabric, the interlacement points becomes welded, they lock. So the deformation behavior of woven fabric when it goes to a composite material changes. But as you know, in composite mechanics, when a fiber reinforced or textile structure reinforced composite is subjected to load, the load transferred from resin to fabric. When resin takes load and it fails, then the load goes to the textile structure, that is reinforcement. At that point, it shows its exoticity. So ultimately, it will show exoticity, but not to that extent as the fabric shows. So this is how, again, another successful research in our center to develop exotic or textile woven exotic materials. You can see where these products are used. Wide range of products, mostly by defense people. Blast resistance vehicle. Exotic material means if you are extending in one direction, it extends in other direction. Means area increases exponentially, square. And wherever you have a blast force, wherever you have a bullet force, wherever you have any penetration, if the area increases, that means the intensity of the penetration falls. So in protective clothing, in ballistic resistance vehicles, in aircraft, in many such applications, in helmets, in packaging materials, defense people, when they drop very sensitive equipment, they make airdrop. Then when that packet falls on the ground, the equipment, sensitive equipment kept inside, they get damaged. But if it is a exotic packaging, then they can be safely dropped without any damage. So there are several applications where the defense people are using. That is what the exotic materials or their composites are getting popularity. However, as I said, there is a lot of challenges. The challenge is composite processing, particularly the selection of what kind of appropriate resin is required to make this composite material. Okay, proceeding further, let us see another structure which are developing, blast resistance composite. So let us understand what is blast and its importance. Blast is the load applied to a structure from a blast wave that comes immediately after an explosion. So it is basically a combination of overpressure and impulse. And if you try to understand what exactly the blast phenomena is, then we need to understand how blast wave propagates in the structure, be it exotic structure, be it a honeycomb structure, or be it any textile structure. Since I have already explained you the behavior of honeycomb structure and the behavior of exotic structure, then we have in our center considered these two materials, exotic and honeycomb, and try to understand out of these two which is giving better blast resistance, so that we can use only that material for these purposes. So these are different type of blast injury. Of course, blast injury depends on many factors. You can see some of the examples here. It basically depends, what will be the blast on a human body depends on how much is the overpressure value and what will be its impact. If overpressure value is 69 kilopascal, the impact is severe, means heart and lungs damage can take place. if the overpressure is about 28 or 30 kilopascal, some fatalities. Or if it is 14, then some common injuries. You can see the common injuries shown in this diagram. So it is mainly used blast resistance vehicles, particularly the platform. And a lot of such vehicles are made by US military force, which are, I have some pictures also, which are being used during Iraq war. So our idea is to develop a structure which gives you better blast resistance. As you know, the performing blast resistance experiment is not allowed in universities, or bullet test is not allowed in the universities. So we have to go for simulation. We develop different structures. We go for simulation study. Then we take any simulation platform. For example, finite element technique is most popular technique, which we have used, and we give input parameter for different structural components, whether it is fabric or composite, what is its thickness, what is its modulus, what is its penetration, and you see, when you go for simulation, you can find out what is the exact blast pressure is generated. So we try to compare this between honeycomb and the auxetic structure. So these two structures are given here, the detail, because as I said, it is now possible to produce structurally stable woven construction, both for honeycomb as well as for auxetic materials. So we develop these structures. The left-hand side is honeycomb, right-hand side is auxetic structures, 3D auxetic structures. Then we convert them to composite material. Then we make this simulation. In this simulation, you can see here what is the loading in case of auxetic and in case of honeycomb. We try to compare what is the experimental value and what is our simulation value. We have a very strong agreement between our simulation and experimental value. The difference or the error is order of 3 to 8%, which is acceptable, and we try to compare their actual performance. Of course, we use different boundary conditions. One can go on changing the boundary conditions depending on actual application values. You can see here in this, the left-hand side, show how blast pressure strike on the surface of the structure, and right side video showing deformation of the structure. And finally, we compare the result obtained both from honeycomb and auxetic. So definitely, the auxetic one is giving superior blast resistance to honeycomb one. So that's the reason why defense people prefer auxetic over the honeycomb one. Okay, time is short, I think almost 40 minutes I have taken. I will take another 10 minutes. The last one, textile structural power composite. This is another sector of our center. So let us understand what is textile structure power composite. Composite is nothing new. It is there since ages. Our wood is a composite material. Human bone or animal bone is a composite material. And composite material today, as I said, glass fiber constitutes 80% of the composite material being produced all over the world. But this composite can be changed to many, many advanced materials. If you look at the evolution of these composite materials, it was there 2500 BC. Look at the pyramid of Cairo in Egypt is 5,000 years old. It's a composite structure. And today, the Dreamliner aircraft, whose body constitutes 65% of the weight, is a composite material. So that's the change from straw and mud bricks to advanced structural composite.
So what is the changes we have made? We are trying to make the material which is lighter. We are trying to make a material which has high fatigue resistance, permeability, moldability, fracture toughness, better anisotropy, corrosion resistance, and the material structure having designability. And we are trying to introduce certain specialty, functions. That means the functions can be introduced in such a manner so that they can be used for these kind of applications. These are the major market today: aircraft, sports, wind turbine blade, bullet train, and so on. So in all these applications, what we are trying to do? We are basically trying to reduce the weights. So that means what we have found, almost 10% reduction in weight can improve fuel consumption by 6 to 7%. So if you look at the theory, that means physics of vehicle weight reduction, look at when a vehicle runs, what is the total vehicle fuel consumption? So vehicle fuel consumption, if you look at this analysis, P is equal to Ft dash minus V upon theta, where Ft is the tractive force. So this tractive force, Ft, is a combination of rolling force, acceleration force, and drag force. If you take the analysis of these three forces, you will find rolling force has a mass component, friction force has a mass component. That means in these three elements, in two elements has a mass component. We have to reduce this mass. If you can reduce this mass, then the tractive force can be reduced, the energy requirement can be reduced, the fuel consumption can be reduced. That is what the whole objective. But apart from that, what we are trying to do, it is not only the reduction of mass, it is not only the reduction of the improvement of the mechanical properties, we can also try to develop some speciality of these materials in which we can add some functionality. So what is this functionality? We broadly classify this functionality into two groups: structural functionality and material, what you call multifunctional composite, that is some functionality, non-structural functionality. Structural functionality can give you strength, stiffness, stability, flexural resistance, ductility. There are many. But non-structural functionality, apart from this mechanical performance, we can also think of energy harvesting, we can think of self-healing, we can think of sensing, actuation. These kind of functionality can also be introduced in composite materials. So that is what the objective of this section, where we are trying to make these composite materials as a supercapacitor. As you know, energy storage in structural composite today is a buzzword in many advanced universities. We are trying to develop a composite material which is a power composite. So what is the vision to develop this power composite? The vision is we need to have a sustainable transportation system. We need to have a very effective wind turbine blade, or we want to have a smartphone in which the energy is not necessary by charging, or we need some slender wings in aircraft. That means the whole idea is to make massless energy storage in electric vehicles. Now the whole world is heading towards make the electric vehicles instead of a diesel car or petrol car. You cannot drive a battery operated car the way we are driving the petrol car or a diesel car. If you want to drive, you have to reduce the weight of the car. So how to reduce? If you use a battery which is about 450 kg, so what is the specialty of the battery? In battery, the mechanical efficiency is 0, electrical efficiency is full. Whereas if you have structural material like composite, where mechanical efficiency is full, electrical efficiency is 0. That means we have to develop a material to balance or to optimize these properties: mechanical efficiency and electrical efficiency. That is what the objective of this research, where we are trying to develop a supercapacitor by simply making a sandwich in which you can use two different fabrics. The top and bottom fabric is some conducting fabric, let us made from carbon fabric. The insulating one, which is separating two layers, is a glass fabric. Make them a sandwich. Top and bottom acts as electrodes. Central one, glass fabric, acts as a separator. And make it a composite material simply by introducing a solid resin. Then look at how is its mechanical performance, how is its electrical performance. The question is, you can do it, but when we develop such kind of structure, the specific capacitance which we have observed is in the order of only 11 millifarad per gram. So question arises, how to enhance this electrical efficiency? Our component is fabric, electrode. We are introducing some resin. So is it possible to introduce some functionality both in the electrode as well as resin so that the overall capacitance of this structure can be enhanced? So that is what we are trying to do. What we are trying to do is, first we are trying to give some functional treatment to the electrode, that is glass fabric, surface treatment, and we are introducing some ionic salt to the solid polymers electrolyte, that is our resin. So it enhances its ionic performance, and that enhances the energy absorbing capacity. So this is how the structure is developed and composite is made. If you give such treatment, so surface treatment by some nanorods, let's say zinc nanorod, then what you find, after giving zinc nanorod treatment to the carbon fiber, you can see the generation of nanorods. And when giving this treatment, make the composite material, you find its electrical efficiency increases multiple times. Instead of 11 millifarad per milligram, we produce about more than 300 millifarad 20 gram, that is, which is a 20 times higher. This is how we have been successfully developed these electrodes made from carbon fabric to be used, the supercapacitor of the composite material, in which the carbon fabric used as the upper layer and the glass fabric as the insulator. So after developing this, the question is how to characterize them. You have to characterize them simply by the plotting the voltage. Look at this. We have a cyclic voltammetry curve. The capacitance increased with the addition of graphene, which is the treatment given to the electrodes. And if you compare it the unmodified solid polymers, so the separation of these two lines, red lines, that means increase in the area between these two lines, will give you indication how effectively we can increase the capacitance. And successfully we have developed this and tried to characterize this. So we measure the specific capacitance, we measure the energy density, we measure the power density. You can see with the addition of graphene, the capacitance has increased from 3.53 to 5.03, and with the addition of the fumed silica, the capacitance has reduced. So this is how this experiment is carried out, and to see or optimize how much graphene you can add so that, and how much ionic salt to be added in the resin so that its electrical performance can be improved. Then after successfully developing this, you make a composite material. then finally go for testing its mechanical performance as you would do in any other composite materials, whether it's a tensile, flexural, impact, etc., for which we are not bothered of because we have already developed many composite materials made from these fabrics. But what is the specialty in this as far as our research is concerned? You see, this sandwich composite has to be very high impact resistance. We have already established in our research, if you want to enhance impact resistance of a composite material, you preferably try to use 3D fabrics. So in this case, simply using a plain woven carbon fabric, we try to use 3D woven carbon fabric as the electrode to be used in this supercapacitor on the top layer and the bottom layer. Then we find, apart from enhancing its electrical efficiency, the mechanical efficiency can also be enhanced. That is what the specialty of our research, where we use 3D fabric as electrode instead of a plain fabric, then we can enhance both mechanical efficiency as well as electrical efficiency. This is how I tried to summarize some of our research. So finally, coming to outlook, what exactly we are looking at or what we foresee in future as far as this development in structural composites are concerned. See, at present, if you look at the 3D fabric or structural composite, it is mainly the application is the defense in safety and protection areas. Transportation industry, where the main aim is lightweighting and fuel efficiency, is another sector. And there is a growing demand in wind turbine blade, that is clean energy. So increasing use of composite textiles or construction industry may be the major market in the years to come. And the last one, auxetic composite and structural power composite are completely, they are in the infancy. That means a lot of research has to be take place in these areas, auxetic as well as structural power composite. Only 2 minutes. So our outlook is lightweighting is the future, in which automobiles, aerospace, marine, construction industry, and wind turbine blade are the major player. 3D printing is going to come in a very big way, in which you can make variety of composite materials. There are several challenges in this area, particularly availability of high performance fibers. Mathematical modeling is very, very important in developing any composite material. We need to know how computational modeling takes place. And production of 3D fabric is very, very expensive because we do not have any commercial machines. So cost of production of 3D fabric is very, very high. Reducing cost is also another challenge. In this area, most of the companies are small companies. So less practical experience, and the skill available is also comparatively low. So we need to have some computer coding, particularly to make engineering design of these materials, because textile industries mostly relies on the practical expertise. They don't believe on the CAD system or engineering design system, reluctant to adopt the modeling principles. So that is also another challenge. If you look at the present perception of this, the composite industry thinking the textile industry to be extremely mature. That means they can develop any preform, whether it is 3D, 2D, auxetic, they can do it easily, which is not true, because it's because in textile, it is little bit difficult. Composite industry assumes 3D fabric forming process are just simply extension of 2D fabric making. That is also not true. Ground reality is something different. You are all textile people, you know development of this structure is not a joke. That's why there is a huge potential, but we need to do lot. Thank you very much for your patient hearing.
So maybe if one or two questions, you just stand here.
Yeah.
Yeah, okay. Just stand here. Thank you, Professor Behera, for your excellent technical speech, especially on structural composite, auxiliary behavior of 3D weaving material. And now we realize there is a long way to go before this 3D weaving is 3D weaving structural composite is a reality. I will just we have our chief guest here. Before calling them into the stage, we'd like to see if there is one or two questions that we could like to take from the audience on to our keynote speaker. Maybe one or two questions. So Professor Dr. Hosnara Begum, I'm just giving you the floor.
Okay. Thank you, Professor, for your nice presentation. I have one question. This is, we know our planet is now in so many pollution. This composite, there are too much resin. This is not biodegradable. And all the composite make a load on our planet. Is it right? We have seen all over the world, so many universities are manufacturing these types of composite, but no one had any result about their impact on environment. How can you see about these things? We are all times express our positive side, all the positive sides of composite. No one tell about the negative side. Please.
Okay, there is a very brief answer to this. Very few people know production of 1 kg cotton makes more pollution or production of 1 kg polyester makes one less pollution.
Yes, cotton makes much more pollution, but it is degradable.
No.
But
we are talking of pollution.
Yeah,
Listen,
but
so that's
yes,
I have not completed answer.
Yes.
If pollution of 1 kg cotton is more than 1 kg polyester, still we call cotton is a bio-friendly material.
Yes.
Similarly, reduction of 40% fuel consumption is more environmental friendly, or generation of resin into the environment is more environment friendly. That we have to compare ourselves. Using composite means reducing 40% or 50% carbon free, means diesel, petrol, which is making our environment carbon free. And in turn, we are using some resin whose impact will come in long term, not in short term. That is what the comparison. But anyway, if you want to live a lavish life, enjoy the whole piece of the world, you have to sacrifice somewhere.
Thank you, Professor. I think you will have a more discussion afterwards. I'm just going to take one more question from somebody. Yeah, there. I think this person. Yeah, you please.
Sorry.
No, I'm sorry. I will just give it to him. Please.
Hello.
Name yourself.
This is MD Rajiur Rahman, Department of Applied Chemistry and Chemical Engineering, University of Rajshahi. So you are talking about the conductivity of anode and cathode, that you are electroplating something zinc oxide to the cathode section. Sir, what is the cost after electroplating system that now we are using the batteries directly in anode and cathode? But the material you have used as composite material, anode and cathode, you are producing like electroplating. So what is the cost effectiveness actually?
Yes.
Thank you, sir.
Very important question. Definitely it is expensive, but question is one time expensive. recurring expenditure for next 15 years is 90% less.
Okay, I think that answers his question. Now we'll be inviting our guest. So thank you very much, our keynote speaker. Now we'd like to invite our guest to the stage. We are requesting our chief guest, Mohammad Assaduzzaman Khan MP, Honorable Minister, Ministry of Home Affairs, Government of Republic of Bangladesh, to come into the stage and take his chair. Honorable Minister Mohammad Assaduzzaman Khan MP. We would also like... Thank you very much. We also have our special guest, Engineer Mohammad Mozaffar Hussain MP, Honorable Member of the Parliament, Jamalpur 5, President Bangabandhu Textile Engineers Association with us. We also have our conference chair, Professor Muhammad Abul Kashem, Vice Chancellor BUTex, in our stage. We also have our conference co-chair, Professor Dr. Shalihuজ্জামান, Dean, Faculty of Textile Engineering, BUTex, is also in the stage. We also have our special guest, Engineer Muhammad Masudur Rahman, President, Textile Engineering Division, IEB, in the stage. And also we have our keynote speaker, Professor Dr. Bijaya Kumar Behera, is also stage. Now, I would like to request our conference co-chair, Professor Dr. Shalihuজ্জামান, to give a speech on this conference. Let me introduce Professor Dr. Shalihuজ্জামান. He have over 30 years of his distinguished career in academia, administration, and industry. He is a Chartered Fellow of the Textile Institute, Manchester, UK, Fellow of the Bangabandhu Fellowship, Government of People's Republic of Bangladesh. He has been one of the members of Revival Project of Muslim, the Golden Heritage of Bangladesh, under the government funding. He has received Public Administration Award 2021 for this work on this Muslim. In his long career, he has been a member of Syndicate, Academic Council, Finance Committee, Procurement Committee, Administrative Council, Academic Council, Planning Committee, and all other committees. So let's welcome Professor Dr. Shalihuজ্জামান.
Dear President, Honorable Minister, Mohammad Assaduzzaman Khan, MP, Minister of Home Affairs, Government of the People's Republic of Bangladesh, Conference Chair, Vice Chancellor of Bangladesh University of Textiles, Professor Muhammad Abul Kashem, distinguished guests and invitees in the audience from home and abroad. Assalamu alaikum and very good afternoon to all. Ladies and gentlemen, it is my very great honor to welcome all of you for today's International Conference on Textile Science and Engineering with a special focus on advanced and sustainable technology for textiles. I am delighted to share with you that this is the first international conference of BUTex, and we are highly determined to keep it up in I would like to express my special heartfelt gratitude to the present Honorable Minister Muhammad Asaduzzaman Khan MP, Ministry of Home Affairs, Governments of the People's Republic of Bangladesh, and joint special guest, Engineer Muhammad Muzaffar Hossain MP, Honorable Member of the Parliament, Jamalpur Pach, and President Bangabandhu Textile Engineers Association, and Engineer Muhammad Masudur Rahman, President Textile Engineering Division, IEB. We are indeed very pleased that you have managed time from your hectic schedule to be with us and to make the conference meaningful. We believe that your proper guidance and direction will enrich our journey to the contribution in textile industry. You know, this is only one textile specialized university in Bangladesh, which was established in 2010 by Honorable PM Sheikh Hasina, who fulfilled the dream of our father of the nation, Bangabandhu Sheikh Mujibur Rahman. I would like to warm welcome Honorable distinguished guest and keynote speaker, Dr. Vijaya Kumar Behera, Professor, Department of Textile and Fiber Engineering, Indian Institute of Technology, Delhi. I am very honored to your presence and your advice, shared knowledge, and epoch-making direction not only help the eminent researcher, but also give big trust to the audience to think new era in terms of advanced textile technology and sustainability. We are in the age of artificial intelligence, and with the advance of artificial intelligence, technology are rapidly changing, following more sustainable way than ever. To enrich modern technology, innovation, and new knowledge related to textile science, such conference will give a big drive to solve industrial problems as well as society in order to make the world in a better place considering sustainability. Now sustainability is the biggest buzzword in line with technological advancement in textiles. I am very optimistic that the conference on advanced and sustainable technology for textile will bring new ideas, innovation, and sustainability to add value to the textile industry. In today's program, from today's first session, we would get epoch-making direction from Chief Guest Muhammad Asaduzzaman Khan MP, Honorable Minister, Ministry of Home Affairs, Special Guest Engineer Muhammad Muzaffar Hossain MP, Honorable Member of the Parliament, Jamalpur Pach, and President Bangabandhu Textile Engineer Association, Special Guest Engineer Muhammad Masudur Rahman, President Textile Engineering Division, IEB. And today's second technical session will be hosted by Dr. Muhammad Ali, Professor, Department of IP, BUTex, and Professor Dr. Moshir Rahman Khan, Dean, Faculty of Fashion Design and Apparel Engineering. Tomorrow's eye-catching technical session 3, 4, and 5 will be conducted by Professor Dr. Muhammad Julhasuddin, Head Department of Wet Process Engineering, Professor Dr. Hosne Ara Begum, Head Department of Yarn Engineering, and Professor Dr. Ummul Khair Fatima, Head Department of Environmental Science and Engineering, BUTex. Hereafter, I will present the Muslim, our invaluable heritage. Finally, the special technical speech session will be presented by the eminent guest participated from the abroad. 3D weaving and technical application, Professor Dr. Vijaya Kumar Behera, it's the IIT Delhi, Textile and Fashion Research Challenges and Opportunities, Dr. Abu Sadat Muhammad Saim, Principal Investigator, AHRC, Digital Fashion Project, Manchester Metropolitan University, UK. Besides, we would love to get insightful advice, direction, and suggestion from Chief Guest Dr. Dipumoni MP, Honorable Minister, Minister of Education, special guest Professor Dr. A.S.M. Maksud Kamal, Pro-Vice Chancellor, University of Dhaka, special guest Dr. Mizanur Rahman, Professor, Department of Marketing, University of Dhaka, and former Vice Chancellor, Jagannath University, Dhaka. Special guest Engineer Muhammad Shafiqur Rahman, President, Institution of Textile Engineers and Technologists, ITT. Altogether, this is going to be a great conference for learning, knowledge sharing, view exchanging, and connecting with eminent researchers from home and abroad. In concluding remarks, I would like to special thank to our conference chair, Honorable Vice Chancellor, and the organizer team. Let's enjoy, excel, and get the best out of the conference, and I wish all of you good luck and all the best. Joy Bangla, long live Bangladesh.
Thank you, Professor Dr. Shah Alimujjaman, conference co-chair, for your valuable speech and importance on innovation, research, and collaboration. Now, I would like to request our special guest, Engineer Mohammad Masudur Rahman, for his speech. Let me introduce him first. Engineer Mohammad Masudur Rahman is a textile engineer, alumni of university. He is a businessman and philanthropist. He is the managing director of Bluebird International Limited. He has been politically active, holding various positions of ITT, including President and General Secretary. Currently, he is the President of Textile Engineering Division of IEB and Senior Vice President of BBTEA. So let's welcome Engineer Mohammad Masudur Rahman.
Assalamu alaikum. The Chair of Conference, Professor M.A. Kasem, Honorable Vice Chairman, Bangladesh University of Textile, the Chief Guest of today's conference, the Honorable Minister, the Ministry of Home Affairs, Government of the Republic, People's Republic of Bangladesh, Bir Muktijuddha, Janab Asaduzzaman Khan Kamal MP, the special guest, Engineer MD Muzaffar Hussain MP, Honorable Member of Parliament, Jamalpur 5, the conference co-chair, Dr. Shah Alimujjaman Belal, Dean Textile Engineering Faculty, BUTex, today's keynote speaker, Professor Dr. Vijaya Kumar Behra, Professor, Indian Institute of Technology, Delhi. Today presents all the faculty members, researchers, experts, BUTex, student of BUTex, media, and distinguished guests and ladies and gentlemen. Assalamu alaikum. First of all, I am giving thanks to the organizing committee who have organized such a beautiful event like this conference, international conference on textile science and technology. For this conference, I think we have got a very good scope to introduce ourselves, our technical things, and all the development we can share through this conference. Ladies and gentlemen, at the outset, I would like to thank the organizing committee who have arranged the first international conference on textile science and technology. Bangladesh University of Textile, also known as the BUTex, has been playing an unparalleled role in developing the skilled textile engineers and technologists who are serving for the textile and apparel industry of Bangladesh. We all know that almost 84% foreign currency earned is from these textile and apparel industries. This sector is working as the main driver of the national economy. Bangladesh export earnings hit the record USD 52 billion in the last fiscal year and set USD 67 billion export target for the year 2022 and 2023 fiscal year. Textile engineers are working relentlessly to achieve the goal set by the Honorable Prime Minister, Her Excellency Sheikh Hasina, to make a smart Bangladesh by 2041, to make it as well as a developed country. I feel proud to be a textile engineer alumnus and a BUTex alumnus. This conference of textile science and engineering has created a nice opportunity to bring a large number of textile researchers, scientists, academics, and practitioners under the same umbrella. I do believe the textile and apparel industry can have very new and innovative ideas through this event that will definitely pave a way to grow the sustainable textile and clothing business. I wish all the success for the conference. মাননীয় প্রধান অতিথি, আপনাকে আপনার অনুমতিক্রমে আমি কনফারেন্সের বাইরে দু একটি কথা, কারণ আপনাকে সবসময় আমরা কাছে হয়তো এইভাবে পাইনি, দু একটি কথা বলতে চাই। সমসাময়িক টেক্সটাইলের কিছু সমস্যা এবং টেক্সটাইল ইঞ্জিনিয়ারদের কিছু সমস্যা নিয়ে আপনার একটু দৃষ্টি আকর্ষণ করতে চাই। মাননীয় প্রধান অতিথি, আপনি শুধু বাংলাদেশের একজন হোম মিনিস্টারই নন, আপনি এ যাবৎকালে একজন সফল হোম মিনিস্টার এবং আপনার নেতৃত্বে এদেশের সন্ত্রাস, মাদক, জঙ্গি, ছিনতাই এবং যাবতীয় সামাজিক অপরাধ নির্মূলের পর্যায়ে চলে এসেছে। তাছাড়াও আপনি যে কনস্টিটিউশনের আপনি অনারেবল সাংসদ, সেই কনস্টিটিউশনেই আজকের এই বুটেক্স অবস্থিত, যা বাংলাদেশের এক্সপোর্ট খাতে যে সেক্টর 84% ফরেন ইনকাম করছে, সেই সেক্টরের কারিগররা আজকে এই বুটেক্স থেকেই বের হচ্ছে। মাননীয় প্রধান অতিথি, আমাদের দীর্ঘদিনের কিছু দাবি আমাদের ছিল যে এই বুটেক্সের আমরা বের হওয়ার পর আমাদের প্রায় সকলকেই বেসরকারি পর্যায়ে আমাদেরকে চাকরি বা জব করতে হয়, অথচ বুটেক্সের বিশেষ ক্যাডার করার মতো মোর দেন 1000 পোস্ট, সরকারি পোস্ট আমাদের রয়েছে। এমন অনেক নজির আছে যে 150-200 পোস্ট নিয়েও মানে ক্যাডার হয়েছে, এরকম অনেক সেক্টরে এর ধরনের ক্যাডার হয়েছে। কাজেই এটা অতীব জরুরি। আপনিও আমাদেরকে, যখন আমরা দেখা করেছি ব্যক্তিগতভাবে, আপনিও বলেছেন যে এই সেক্টরকে মানে এই সেক্টরের উন্নয়নের জন্য বিশেষ ক্যাডার অতীব জরুরি। মাননীয় প্রধান অতিথি, আজকের এই অনুষ্ঠানের মাধ্যমে, যদিও এটা একটি কনফারেন্স, এই অনুষ্ঠানের মাধ্যমে আপনার নিকট আমাদের আবেদন, এই বিশেষ ক্যাডার করার জন্য বর্তমান যে সংসদে যে অধিবেশন চলছে, আমাদের মাননীয় সাংসদ, আমাদের এমপি, এই বুটেক্সের এই অহংকার মুজাফফর সাহেব, উনিও এখানে উপস্থিত আছেন। ওনার মাধ্যমে আমি বলবো যে আপনি সম্পূরক প্রশ্নে আপনি এই টেক্সটাইল বিশেষ ক্যাডারের ব্যাপারে সংসদে উত্থাপন করবেন এবং মাননীয় স্বরাষ্ট্রমন্ত্রী, আপনার নিকট আমাদের আবেদন যে আপনি এটাকে যাতে বাস্তবায়ন করা হয়, যে ধরনের পদক্ষেপ নেওয়া দরকার আপনি সে ধরনের পদক্ষেপ নেবেন। মাননীয় প্রধান অতিথি, আপনি 2009 সালে এই এলাকার সাংসদ হিসেবে নির্বাচিত হওয়ার পর আমার সৌভাগ্য হয়েছিল 2009 সালে আমার যে প্রফেশনাল ইনস্টিটিউশন রয়েছে সেই ইনস্টিটিউশনের প্রেসিডেন্ট হওয়ার। 2009 সালে এই প্রেসিডেন্ট হওয়ার সুবাদে 2009 সালে আমাদের টেক্সটাইলের যে এই কলেজটাকে বিশ্ববিদ্যালয়ে উন্নীত করার যে ফাইল, সেই ফাইলটুকু সচিব কমিটি থেকে ব্যাক করা হয়েছিল। তৎকালীন প্রিন্সিপাল মাসুদ সাহেব আমাকে এবং আমার সেক্রেটারিকে ডেকে এই ফাইলটা আবার কিভাবে মানে ব্যাক করা যায় সে ব্যাপারে নির্দেশনা দিয়েছিল, এবং আমি আপনার সহযোগিতায় আপনার নেতৃত্বে 2009 সালে আমরা সেই ফাইলটাকে ব্যাক করে ইউনিভার্সিটি বাস্তবায়নের কাজ শুরু করি, এবং আপনার সফল নেতৃত্বে আপনার হাত ধরেই এই কলেজকে 2010 সালে মাননীয় প্রধানমন্ত্রী ইউনিভার্সিটি হিসাবে ঘোষণা করেন। আমরা বুটেক্স পরিবার যখনই কোনো সমস্যায় পড়েছি আপনার দ্বারস্থ হয়েছে, এবং আপনি দুহাত বাড়িয়ে আমাদেরকে সমস্যামুক্ত করেছেন। মাননীয় প্রধান অতিথি, অত্যন্ত দুঃখজনক যে এমনিতেই আমাদের এই যে ইন্ডাস্ট্রিগুলো খুঁড়িয়ে খুঁড়িয়ে চলছে, গ্যাসের অভাব, গ্যাসের যে প্রোডাকশনের 1/3 প্রোডাকশন গ্যাসের জন্য অর্জিত হয় না। কিন্তু হঠাৎ করে গত কিছুদিন পূর্বেই আমরা হঠাৎ করে দেখতে পেলাম একটি পরিপত্র এসআর জারি করা হয়েছে। গ্যাসের মূল্য 1 লাফে বয়লারের গ্যাস 12 টাকা থেকে 30 টাকা এবং ইন্ডাস্ট্রিয়াল গ্যাস 16 টাকা থেকে 30 টাকা করা হয়েছে। মাননীয় প্রধান অতিথি, আপনি জানেন এই সেক্টরে প্রায় 20,000-এর উপর টেক্সটাইল ইঞ্জিনিয়ার কর্মরত এবং মোর দ্যান 45 লাখ ওয়ার্কার, বিশেষ করে মহিলা ওয়ার্কার এই শিল্পের সাথে জড়িত। আজকে যদি এই গ্যাসের এই দাম বৃদ্ধির কারণে যদি এই শিল্প যদি আজকে ধ্বংস হয়ে যায় বা ধ্বংসের দ্বার প্রান্তে পৌঁছায়, এটা সমস্ত দেশে একটা ডিজাস্টার বয়ে নিয়ে আসবে। কাজে আজকের এই অনুষ্ঠানের মাধ্যমে মাননীয় প্রধানমন্ত্রী আপনার নিকট আমাদের আবেদন, এই গ্যাসের দাম বৃদ্ধির যে বৃদ্ধির এটাকে পুনর্বিবেচনা করে 1 লাফে এত না বাড়িয়ে মাঝামাঝি পর্যায়ে একটি স্থানে এই গ্যাসের মূল্য বৃদ্ধি করা যায় কিনা সে ব্যাপারে আপনি আমাদের পক্ষ থেকে, টেক্সটাইল ইঞ্জিনিয়ারদের পক্ষ থেকে, সমস্ত টেক্সটাইল সেক্টরের পক্ষ থেকে আপনি এই ব্যাপারটা পুনর্বিবেচনার জন্য যারা এই সেক্টরের সাথে জড়িত তাদেরকে বিনীতভাবে আপনি আহ্বান জানাবেন। এই বলেই আমি আমার বক্তব্য এখানে শেষ করছি। জয় বাংলা, জয় বঙ্গবন্ধু।
Thank you, Engineer Mohammad Masadur Rahman. We'd like to add to the voice to him that we really want BCS textile cadre. I hope that will happen with our chief guest. Now we'd like to request our special guest, Engineer Mohammad Mozaffar Hossain MP, for his speech. Let me introduce him a bit. He is the Honorable Member of the Parliament, Jamalpur 5, President, Bangabandhu Textile Engineers Association, Member, Parliament Committee of Science and Technology, Bangladesh National Parliament. He has 31 years of business experience and currently the founder and managing director of SIM Group and Mozaffar Spinning Mill. He is also an alumni of the university and sits down in various committees. So let's welcome Engineer Mohammad Mozaffar Hossain, MP.
Bismillahirrahmanirrahim. Good evening. Today is the International Conference, Textiles and Engineers. The chief guest, our Honorable State Minister, Janab Asaduzzaman, the President, the Vice Chancellor of Abul Kashem, and special guest Masudur Rahman, and the main arrangement man Alimunur Jaman, and main keynote speaker Bijoy Kumar Bihara, present the ordinance, the dean, professor, students, and comes from various universities. Ladies and gentlemen, Assalamu alaikum. Today's seminar, I have some time to see and listen. It is a big, for me, it's a big, difficult for understand. So now I tell to you, speak in Bengali. বাংলায় আমি কথা বলবো। কারণ হলো আমরা বাঙালি, আমরা বাংলায় কথা বললে আমরা ভালো বুঝি। ইংলিশ যে ভাষায় যে সাবজেক্ট, এটা আমার দ্বারা বোঝা কোনোভাবেই সম্ভব না। হ্যাঁ, যদি পড়াশোনা করতাম তাহলে হয়তো বুঝতাম। তো অত্যন্ত গুরুত্বপূর্ণ, এটা বুঝেছি। কম্পোজিট টেক্সটাইল বলতে যেটা বুঝেছি, এটা আমাদের দেশে এখনও কিছুই শুরু হয় নাই। আমি কিনিউট স্পিকারকে জিজ্ঞাসা করেছি, ওনার দেশে কেবল শুরু হয়েছে, রিসার্চ হয়েছে, কিছুটা শুরু হয়েছে। আমি আশা করি এই সাবজেক্ট যে ব্যবস্থা করেছে, আমি ধন্যবাদ জানাই এই বুটেক্স অ্যাডমিনিস্ট্রেশন, বিশেষ করে আলিমুজ্জামানকে। সে অত্যন্ত দৌড়াদৌড়ি করে আমাদেরকে ইনভাইট করে এনেছেন, যে খুব গুরুত্বপূর্ণ। আমরা টেক্সটাইলে আজকে 85% আর্নিং করি ফরেন কারেন্সি টেক্সটাইল সেক্টর থেকে। এর ভিতরে আপনারা সবাই হয়তো সব কিছুই জানেন, যারা নিটে উভেনে খুবই কম। দিস সাবজেক্ট ইজ টোটালি উভেন সাবজেক্ট, যে ভেরি ম্যাথমেটিক্যাল অ্যান্ড ফিজিক্সে যারা ভালো জানেন তারাই এই সাবজেক্ট বুঝতে পারেন ভালো। তা আমি বিশ্বাস করি এখানে অনেক টিচার আছে, ওই যে রাজশাহী থেকে এক টিচার আসছেন, উনি প্রশ্ন করেছেন, এরকম আমার এখানেও অনেক টিচার আছেন, তারা রিসার্চগুলি করেন। আমার বুটেক্সের রিসার্চের মনে হয় এই জিনিসটা প্রচলিত নাই। আমি আশা করব আগামীতে আপনারা রিসার্চ করে, আজকে বিজয় কুমার বেহারা যেভাবে আমাদেরকে বুঝাইলেন, আমি হয়তো বুঝলাম না, অনেকে হয়তো বুঝছেন। হ্যাঁ, আমি বুঝছি, আমি যেটা বুঝার সেটা বুঝেছি, যে এটা অত্যন্ত হাই টেকনোলজি। আমাদের আগামীতে ফোর্থ রিভলিউশনে এই হাই টেকনোলজি বেশি প্রয়োজন। আমি এটাও জানি এরোস্পেসে আমাদের এই ফ্যাব্রিক থেকে এমন ফ্যাব্রিক তৈরি করা হয় যেটা এরোস্পেস, এই উড়োজাহাজে যেটা আমেরিকায় ব্যবহার হয়, যুদ্ধ জাহাজে। যদি কোনো যুদ্ধ জাহাজ বিধ্বস্ত হয়, সেই জাহাজ কোথায় বিধ্বস্ত হলো, এই কাপড়ের তৈরি যে এরোস্পেসে ব্যবহার হচ্ছে, সেটা দিয়ে ইন্ডিকেট করা যায় যে অমুক জায়গায় এই যুদ্ধ জাহাজটা বিধ্বস্ত হয়েছে। সেই টেকনোলজি আজকে এই বিজয় কুমার বেহারা এক্সপ্লেন করেছে। আমি বুঝেছি কম্পোজিট ফাইবার, গ্লাস ফাইবার, সব ফাইবার সম্বন্ধে কিছুটা আইডিয়া আছে। তবে এটাকে বুঝতে হলে রিসার্চ করতে হবে, রিসার্চ করে আমাদের প্র্যাকটিক্যালি নিয়ে আসতে হবে। আজকে আমরা যেভাবে 85% ফরেন আর্ন করছি, এটার মূল কারিগর হলো আপনারা টেক্সটাইল ইঞ্জিনিয়াররা। আমাদের ওই বাসুদ যেটা বলেছে, দুঃখজনক হলো সত্য। আমি প্রেসিডেন্টের মহামান্য রাষ্ট্রপতির ভাষণের উপর আমার বক্তব্য দিয়েছি। আমি সব কিছু রেডি করে নিয়ে গিয়েছি। এই টেক্সটাইল সেক্টর থেকে যে আর্নিং হয়, সেই কথাগুলি বলার পর আমার সময় কমে যাচ্ছে, আমি চলে গেছি আমার গ্রামের দিকে। আমি এই টেক্সটাইল বিসিএস ক্যাডারের ব্যাপারে আমি সব কিছু লিখে নিয়ে গেছি, কিন্তু আমি বলতে পারিনি। তার আগেও আমি কয়েকবার সংসদে বলেছি, শিক্ষামন্ত্রীর সাথে আমার কথা হয়েছে, আমাদের নেতা আমাদের স্বরাষ্ট্রমন্ত্রী, ওনার সাথেও আমাদের কথা হয়েছে। তবে এটা অনেক কঠিন কাজ না, আবার কঠিনও। যে বিসিএস ক্যাডার যেখানে 66 জন পোস্ট খাদ্য বিভাগে, সেখানে বিসিএস ক্যাডার আছে। আর আমাদের প্রায় 500 এন্ট্রি পোস্ট, ফার্স্ট ক্লাস পোস্ট 500, 344 জন আছে ডিপার্টমেন্ট অফ টেক্সটাইলে, যেখানে অধিদপ্তর, আর অন্যান্য যে এই বস্ত্র দপ্তর, শিল্প, রেশম, তাঁত, এই জুট রিসার্চ, এনবিআর, এরকম ড্যাডো, যে সব মিলিয়ে আমাদের 500-র উপরে পোস্ট, আমাদের ফার্স্ট ক্লাস পোস্ট। আজকে আমাদের টেক্সটাইল ইঞ্জিনিয়াররা, আমার প্রধান অতিথিকে লক্ষ্য করে বলছি, আজকে আমাদের টেক্সটাইল ইঞ্জিনিয়াররা এ পর্যন্ত প্রায় 30 জন টেক্সটাইল ইঞ্জিনিয়ার পুলিশে এই এডিশনাল এসপি হিসেবে জয়েন করেছে। আমাদের এই জ্ঞান গরিমা অর্জন করে আমরা পুলিশের দিকে আপনার সাবজেক্টের দিকে গেছে, আপনার ডিপার্টমেন্টের দিকে গেছে, কিন্তু আমরা তো এটা চাই না। আমরা চাই আমাদের টেক্সটাইল ইঞ্জিনিয়াররা টেক্সটাইলের উপরে থেকে বিসিএস ক্যাডার অর্জন করে আমাদের ভিন্ন জায়গায় আজকে সরকার রাজস্ব হারাচ্ছে। আজকে চিটাগাঙ্গে কেমিক্যাল আসে, কাপড় আসে, চূড়ায় পথে চলে আসে, বা কোনো টেস্ট ছাড়াই যারা টেস্ট করে টেক্সটাইল ইঞ্জিনিয়ার তেমন না। আগে কিছু ডিপ্লোমা ছিল, এখন কোনো টেক্সটাইল ইঞ্জিনিয়ার আছে বলে আমার মনে হয় না। এরকম প্রত্যেক ক্ষেত্রেই এই আমাদের বিমানবন্দর থেকে শুরু করে অনেক ক্ষেত্রেই টেক্সটাইল ইঞ্জিনিয়ারদের প্রয়োজন। এটা হলেও বাংলাদেশের রাজস্ব বৃদ্ধি পাবে, প্রকৃত মানুষ প্রকৃত জিনিস অর্জন করতে পারবে। এগুলির জন্য আমাদের বিসিএস করা অত্যন্ত জরুরি, অত্যন্ত জরুরি। এটা আপনার সহায়তা পেলে আমরা এই বিসিএস ক্যাডার এই 1 বছরের ভিতরে না হলেও আগামীতে তো ইনশাল্লাহ আমরা সরকারে আসতেছি ইনশাল্লাহ। আপনি হয়তো আবারও স্বরাষ্ট্রমন্ত্রী হবেন, সেই ক্ষেত্রে বিসিএস ক্যাডারটা আপনার মাধ্যমে অর্জন করতে পারি, যেভাবে আপনার মাধ্যমে অর্জন করেছি এই ইউনিভার্সিটি 2011 সালে। আপনার অক্লান্ত পরিশ্রম, আরও অন্যান্যরা যা আছেন তাদেরও সহায়তা ছিল, শিক্ষামন্ত্রীর সহায়তা ছিল, আরও আমাদের লতিফ সিদ্দিকী বস্ত্রমন্ত্রী ছিল, ওনারও সহায়তা ছিল। এগুলি আমরা কৃতজ্ঞতা স্মরণ করি। কিন্তু আপনার কনস্টিটিউশনে এই স্পেশাল একটা টেক্সটাইল ইউনিভার্সিটি, যেটা আমার বাংলাদেশে আর কোথাও নাই, তাই এখানে বিসিএসের জন্য আপনার সহায়তা আমাদের প্রয়োজন। আপনি অত্যন্ত ভালো লোক, আপনি আমাদের সহায়তা করলে ইনশাল্লাহ আমরা এটা অর্জন করতে পারবো। আমি আর বেশি কিছু বলতে চাই না, আমি একটা কথাই বলতে চাই, এই যে কঠিন একটা সাবজেক্ট আলিমুজ্জামান নিয়ে আসছে, আগামী দিনে যেই বিসি হয় আর 1 মাস 1.5 মাস পরে বিসি হবে, তার মাধ্যমে যাতে আমরা এইরকম সাবজেক্ট যাতে আমরা না বুঝলেও আমার যারা ছাত্র, আমার যারা টিচার, তারা রিসার্চ করে এই যখন রেজাল্ট যেন আমরা প্র্যাকটিক্যালি দিতে পারি, এই আশা ব্যক্ত করে জননেত্রী শেখ হাসিনার জন্য আপনাদের কাছে সবার দোয়া চেয়ে বঙ্গবন্ধু বিদেহী আত্মার মাগফিরাত কামনা করে আমি আমার বক্তব্য শেষ করছি। জয় বাংলা, জয় বঙ্গবন্ধু, বাংলাদেশ চিরজীবী হোক। আসসালামু আলাইকুম।
Assalamu alaikum, and a very good evening to all of you. Thank you very much, Engineer MD Muzaffar Hussain, MP, for your valuable speech. I have learned that each textile that made the spirit, skill, and personal history of an individual textile expert. It ties together with an endless thread of the emotional life of our people, and the BUTex will be the scientific and innovation hub of the world near future. Through our distinguished teachers and students who were directly linked with our industrial revolutions. We're all aware that our Honorable MD Asaduzzaman Khan, MP, Minister of Home Affairs, Government of the People's Republic of Bangladesh, is our chief guest today. MD Asaduzzaman Khan is a notable member of the Mukti Bahini and the Bangladesh Awami League. He participated in Sector 2 of the 1971 Bangladesh Liberation War. He presents Dhaka 12, and in 2014, after demonstrating his leadership skills, he was appointed State Minister of Home Affairs. 1 year later, in 2015, he has been appointed as the Minister of Home Affairs. We BUTex family are very fortunate to have MD Asaduzzaman Khan is a local guardian of Tejga residents. We hope that, as we have seen many times before, he will continue to look after BUTex affairs in the future with all his kind means and advice. Now, it's a great moment to enjoy the valued speech of the chief guest of this program. On this occasion, I would like to request on stage MD Asaduzzaman Khan, MP, Honorable Minister, Ministry of Home Affairs, Government of the People's Republic of Bangladesh, to present his words in his language. Sir, please.
International Conference on Textile, Science and Technology. Conference Chair, Mr. Abul Qasim, Vice Chancellor of BUTex. Special guest, Engineer Muzaffar Hussain MP. He is also a student of this previously college, now it is university. Special guest, Engineer Masudur Rahman, President of Textile Engineering Division. Professor Vijay Kumar Behra, Professor of Indian Institute of Technology. He was most probably keynote speaker of this session. Dear participant, respected teachers and guests, it is my honor and privilege to give my inauguration speech of the first International Conference on Textiles, Science and Engineering organized by Textile University of Textiles, a remarkable institute of South Asia, worth notable for important on the textile sector, the economic backbone of Bangladesh. Since its origin, 1921, this institute was noted and produced extraordinary textile engineers, researchers, and noble citizens who are leading and facilitating textile sector of our country. It is a great pleasure for me to stand on the center from which the knowledge of textile is imparted all across the country, and to experience the first ever International Conference on Textile Science and Engineering of such caliber. I express my heartfelt gratitude to Professor Mr. Abul Qasim, the Vice Chancellor of Bangladesh University of Textile, acting as a conference, the chair, and all the members of the organizing committee for arranging such significant event. It is truly an impactful stance in this university because there is no alternative to give a special focus on research and development of advanced sustainable technology for textile to manifest our Honorable Prime Minister Sheikh Hasina's every citizen's dream for achieving 100 billion RMG export by 2030. I want to continue rest of my speech in Bengali. বাংলাদেশ তৈরি পোশাক খেতে গত 2 দশকে আমরা চমৎকারভাবে এগিয়েছি। 2021-22 অর্থবর্ষের তৈরি পোশাক রপ্তানি প্রায় 42 বিলিয়ন মার্কিন ডলার, যা দেশের সম্পূর্ণ রপ্তানির 81%। সুতরাং এই খাতটি বিশ্বের দ্বিতীয় বৃহত্তম পোশাক রপ্তানিকারক দেশের আমরা এখানে এসে দাঁড়িয়েছি, অস্বীকার করার কোনো উপায় নাই। আর এই মেরুদণ্ডকে বাঁচাতে হলে প্রয়োজন শিক্ষিত জনবল, যারা চিন্তা করতে জানেন, তাদের ধী শক্তি দ্বারা কর্মক্ষেত্রে ঘটে যাওয়া সমস্যাগুলির সমাধান দিতে জানবেন। এই সম্মেলনের শিক্ষার্থী, শিক্ষক তাদের কাজে যা অতীব আগ্রহ দেখে আমি নিশ্চিত বিশ্ববিদ্যালয় ঠিক এই কাজটি করে যাচ্ছে। আমাদের টেক্সটাইল এবং গার্মেন্টস শিল্প সময়ের সাথে তারা খাপ খেয়ে চলছে। আমি যদি ঘুরে আসি সর্বকালের সর্বশ্রেষ্ঠ বাঙালি জাতির পিতা, যখন তিনি মিনিস্টার ছিলেন তখনই প্রথমে এসে এই টেক্সটাইল এটা ইনস্টিটিউট বলা চলে না, আমি যে 1921-এর কথা বলছি, স্কুলের মতো ছিল। তিনি তখন এসে বললেন যে এখানে এটা আর একটা বড় করতে হবে, বৃহৎ করতে হবে। কারণ জনগণের মেইন ডিমান্ড কি? খাদ্য, খাদ্যের পরে যেটা কি বস্ত্র। সেই বস্ত্রর একটা জায়গা থাকবে না যেখানে নলেজ শেয়ার করবে, যেখানে তারা নলেজ গেদার করবে। সেই জন্যই তিনি এই পলিটেকনিক ইনস্টিটিউটের সঙ্গে এটারও করার জন্য তিনি মানে শুরু করে দিয়েছিলেন, এটাকে আরও মানে ইমপ্রুভ করার জন্য। সেটাই তারই কন্যা জননেত্রী শেখ হাসিনা এই খাতকে প্রাধান্য দিয়ে, এই খাতের আমরা লক্ষ্য করেছিলাম যখন আমরা এই খাতে আমরা যথেষ্ট শক্তিশালী হয়েছিলাম, আমাদের বিভিন্ন বিদেশের বিভিন্ন দেশ থেকে আমাদের এক্সপার্ট নিয়ে আসতে হতো। আমাদের পার্শ্ববর্তী দেশ, ভাতৃপ্রতিম দেশ ইন্ডিয়া তো বটেই, এবং আমাদের শ্রীলঙ্কা এবং অন্যান্য দেশের থেকে আমরা আমাদের এক্সপার্ট নিয়ে আসতাম। এখন আমরা পারছি, আমাদের ইয়াং জেনারেশনরা এগিয়ে আসছে। শুধু এই ইউনিভার্সিটি না, বাংলাদেশের সব জায়গায় টেক্সটাইল ইঞ্জিনিয়াররা তাদের অত্যন্ত দক্ষতার সঙ্গে তাদের মেধা দিয়ে আমাদের সেই জায়গাটাতে নিয়ে গিয়েছে। সেই জন্যই আজকে আমরা দ্বিতীয় স্থানে, রপ্তানির দ্বিতীয় স্থানে চলে আসছি। আমরা মনে করি আমরা খুব শীঘ্রই চতুর্থ শিল্প বিপ্লবের মুখোমুখি হতে যাচ্ছি। সেখানে কি হবে, কোন জায়গা দিয়ে আমরা আরও এগিয়ে যাব, সেইটা নির্ভর করে আমাদের এই প্রজন্মের ওপর। আমাদের ভরসা রয়েছে এই প্রজন্ম 2041-এ আমাদের সেই জায়গায় নিয়ে যাবে, আমাদের স্বপ্নের জায়গায় নিয়ে যাবে। আমাদের খাদ্যের পাশাপাশি আমাদের সর্বকালের সর্বশ্রেষ্ঠ বাঙালি বলে গিয়েছিলেন, স্বপ্ন দেখতেন এদেশ একটা অসাম্প্রদায়িক চেতনার বাংলাদেশ হবে, এখানে হিন্দু, মুসলমান, বৌদ্ধ, খ্রিস্টান মিলেই বাংলাদেশ। আমরা সবারই রক্ত ঝরেছিল এই বাংলাদেশে। তিনি গ্যারান্টি দিয়েছিলেন এই অসাম্প্রদায়িক চেতনার দেশে সবার জন্য বাসস্থান হবে, সবার জন্য শিক্ষা হবে, সবার জন্য খাদ্যের ব্যবস্থা হবে, এবং পাশাপাশি যেটা সবচেয়ে প্রয়োজন, আমরা অন্ন বস্ত্র যেটাকে সবসময় বলি, সেই বস্ত্রের প্রয়োজন হবে। সেটার জন্যই আমরা এই খাতকে শক্তিশালী করতে চাই। প্রবলেম আছে, প্রবলেম সলভ হবে। আমাদের মাসুদ ভাই, আমাদের ভিসি মহোদয় কানে কানে বলছিলেন টেক্সটাইল ক্যাডার সার্ভিসে আমার অন্তর্ভুক্ত হয়নি, সেই জন্য আমরা বিসিএস ক্যাডার টেক্সটাইল ইঞ্জিনিয়ারের স্থান পাচ্ছে না। আপনারা দাবি তুলেছেন, আমি মনে করি এটা যৌক্তিক দাবি। আপনার অন্য ইঞ্জিনিয়ারদের মতো আপনাদেরকেও সেই জায়গা সার্ভিসে যাবেন, এটি আমরা বিশেষ করি। সঙ্গে সঙ্গে আরও কিছু প্রবলেম আছে, সেগুলো আমাদেরকে সলভ করে এগোতে হবে। আমি সেটির জন্য আমি বলছি, প্রবলেম আসবে, প্রবলেম সলভ হবে, আমরা এগিয়ে যাব। তা আমাকে এই জায়গায় কিছু বলার সুযোগ দেওয়ার জন্য আপনাদের যারা অর্গানাইজার তাদেরকে আমি ধন্যবাদ জানাচ্ছি। আমি কিনোট যিনি প্রেজেন্ট করলেন, আমি তার বক্তৃতার শেষ মাথায় আসছিলাম, কাজেই আমার দ্বারা কিছু শোনার সম্ভব হয়নি। শুনলে হয়তো আমার জ্ঞানের পরিধিটা আরেকটু বাড়তো, আরেকটু আমি মানে তার থেকে নলেজ গেদার করতে পারতাম। সৌভাগ্য নেই এবং হয়ও নেই, সেই জন্যই আমি শুধু দুঃখ প্রকাশ করি এখান থেকে চলে যেতে হচ্ছে। এটা সুন্দরভাবে হবে আমাদের যে ছেলেরা কিংবা আমাদের শিক্ষকরা যারা এখানে পার্টিসিপেট করছেন, সারা বাংলাদেশ থেকে আসছেন যারা, তারা চর্চা করবেন এইখান থেকে কিছু মানে আমাদের বিদেশি যে গেস্ট আসছেন, যে স্পেশালিস্ট আসছেন, তাদের থেকে আপনাদের জ্ঞানও শেয়ার করবেন, তাদের জ্ঞানও আপনারা গ্রহণ করবেন। এইটাই আমরা মনে করি সেটাই হবে। আর আমি সবসময়ই আমরা বুক ফুলিয়ে বলি, আমাদের 65% আমাদের পপুলেশনের হলো ইয়াং জেনারেশন, যারা নাকি কর্মক্ষম। কাজেই আমাদের যাত্রা কেউ বন্ধ করতে পারবে না। আমরা আমাদের টার্গেট মতোই যাব। আমরা 2041-এ আমরা একটা মানে সমৃদ্ধ বাংলাদেশ, উন্নত বাংলাদেশে আমরা অবশ্যই যাব। সেজন্যই টেক্সটাইল ইউনিভার্সিটিও যুগের সঙ্গে তাল মিলিয়ে তারাও এগিয়ে যাবে, এটাই হলো আমাদের সবারই আকাঙ্ক্ষা। এই কনফারেন্সটা সুন্দর হোক, সার্থক হোক এবং মত বিনিময়ের জায়গাটা আরও সুন্দর হোক। প্রতি বছর না হলেও একটা ইন্টারভেলের মাধ্যমে আপনারা এই অনুষ্ঠানগুলি করবেন, যাতে আপনারা আপনাদের জ্ঞানের চর্চা এবং আপনাদের এক্সপেরিয়েন্স শেয়ার করতে পারেন। সবাইকে ধন্যবাদ রইল, ভালো থাকবেন। জয় বাংলা, জয় বঙ্গবন্ধু, বাংলাদেশ চিরজীবী হোক।
Thank you, the chief guest, for your uplifting, insightful, and guided speech. This is a very, I would say, important for a young generation like you guys. And also, thank you for agreeing to our proposal for BCS Textile Cadre. Now, we will be giving crest to our special guest and chief guest. First, I would like to request our conference co-chair, Professor Dr. Shalimujjaman, to be crest to our special guest, Engineer Muhammad Masudur Rahman. So, yes. The next crest will go to our another special guest, Engineer Muhammad Mojaffar Hussain MP. Muhammad Mojaffar Hussain MP, and also conference co-chair to provide the guest. Now, our final crest to our chief guest, and that I request our conference chair, Professor Muhammad Abul Kashem, Vice Chancellor of BUTex, to provide to our Honorable Minister, Engineer Muhammad Asadul Jaman Khan MP. Still, there is one more gift for the chief guest from the BUTex. I would like to request conference chair to give the gift to our chief guest. This is a special gift from BUTex for the chief guest and his family. This is a textile gift, handcrafted. Thank you very much. So thank you for the guest. And now we'll take a break, a prayer break. We'll come back by 6 o'clock. So we'll see you there. We'll have a next session. Thank you very much. Just to let you know, we'll be back at 6 o'clock. Let's have a prayer break and tea break. Thank you.
Hello, 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 check. Hello, hello, check.
বন্ধ করে দিবেন কয়েক সেকেন্ড জাস্ট।
Hello. Hello.
নেক্সট কালকে ফুলগুলো নিচে দেন।
না না, ফুলের জন্য না।
একটু দেন কথা বলি। হ্যালো 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 চেক চেক হ্যালো 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 হ্যালো
এটা কাজ করে কিনা একটু দেখতে যাচ্ছি। আচ্ছা, কোনো
হ্যালো
পিপিটি আমি অন করে
হ্যালো
দিচ্ছি।
চেক চেক চেক
হ্যালো,
হ্যালো
আসসালামু আলাইকুম।
হ্যালো
সবাইকে রিকোয়েস্ট করছি পরের সেশনে আসার জন্য। উই আর অলরেডি 5 minutes behind the schedule. হ্যাঁ, ঠিক আছে, এখানে হচ্ছে ওইটার সাথে নিয়ে। ঠিক আছে। এবার আপনি করেন। আচ্ছা, we are checking if the technical session speakers are here, and also we'll have a speech of our conference chair, Professor Muhammad Abul Kashem. So we are requesting everyone to take their seats and also come to the auditorium. Those who are waiting outside, please come back to the auditorium.
ল্যাপটপের অডিওটা একটু চেক করেন, পডিয়ামেরটা। ওকে,
কপি করে নিয়ে আসি। Requesting our organizing committee for the organizing committee of the conference, we are requesting you to bring our conference chair, Professor Muhammad Abul Kashem, Vice Chancellor, to start the next session.
Check. Hello.
Then
Hello. 300 years ago, people couldn't imagine they could fly or use a mobile phone. They couldn't imagine that they could see each other on the screens. If you say that type, it's a magic, and this magic has been formed true by the science and innovation. BUTex starts a scientific international events, and it has been made by our Honorable Vice Chancellor, sir. First of all, I would like to say something about our Vice Chancellor, sir. Professor MD Abul Kashem has a long academic and administrative career spanning more than 40 years. Before being as the Vice Chancellor, he was appointed as a head, Department of Apparel Engineering, and also Dean, Faculty of Fashion Design and Apparel Engineering. He also served as the Honorable Chairman, Technical Education Board, Bangladesh, over a period for 5 years. Now, I would like to request at this stage Professor MD Abul Kashem, Honorable Vice Chancellor of BUTex, for his valuable speech in his language. Sir, please come.
Good evening, ladies and gentlemen. First international conference organized by Fabric Engineering Department of BUTex on textile science and engineering. Honorable Chief Guest, although he has left due to his important assignment in the assembly, MD Asaduzzaman Khan, Honorable MP and Ministry of Home Affairs. Honorable Special Guest, Engineer Muzaffar Hussain, MP, Jamarpur 5. Special Guest, Masudur Rahman, President, Textile Engineering Division, IEB. Keynote Speaker, Mr. Behera, Professor, IIT Delhi. Co-Chair, Dr. Shah Alimuzzaman. All the deans, head, and honorable teachers, and representative from different organizations. I welcome you all in BUTex to this conference. We have seen that the presentation done by Mr. Behera, I found it very, very interesting, and quality of research he is doing, I am highly impressed. I am highly impressed. And there is also another session by him tomorrow. I think that session will also be interesting. BUTex, established 12 years ago, could not arrange any international conference. This is the first time we are organizing this conference. Although we have lot of hurdles, lot of problems to organize this conference, but finally it held. And we are happy. I think our faculty members, our officers, staffs, specifically our students, present students, they are highly excited when they knew that this conference is going to be held in BUTex. And as a university, conference is a normal issue, as usual issue, but it is new for us. I think through this conference, we get the opportunity to know a lot of research issues, lot of innovation, and we can exchange our knowledge. You know, one of our special guests mentioned that although he is a textile engineer, and he was telling that I could not understand anything. Being a textile engineer, he told that so impressed with the last presentation that we have seen. It was also out of my imagination. But when I see the presentation, it was very interesting for me, and I think it is also interesting for you. To organize this program, lot of efforts has been given by the organizing committee. They had to face lot of problem. They came several times to me to discuss how they can proceed, how they can exceed. Actually, we had no experience earlier to organize a international conference. As because we mentioned, this is first time from BUTex. And this time we are learning, and next time it will be very easy for us to organize. I think, I believe. And I also expect that every year at least one international conference will be organized by BUTex. And we have taken decision, already we have taken decision that each year at least one department will get chance to arrange this type of international conference. And funding will be done, funding will be arranged by BUTex. So funding will not be a problem, as because it will be arranged in our revenue budget. So it will be easy for us. And you know, we have session today also, and also tomorrow whole day. Technical sessions from 9 a.m. to, I think, up to evening. And I invite all of you to attend tomorrow's program also, so that you can learn something, you can exchange your idea, and get motivated. Specifically, our teachers, many of our teachers are now engaged in research activities. We are providing sufficient fund for research activities. Still we have fund. If anybody approach, we can provide fund. We have still fund in our hand. So I believe that fund is not the problem for taking research project. And young teachers, they should come forward. Senior teachers may cooperate, so that research activities may be strengthened. All of us know that university is the place where research and innovation, where knowledge will be created and it will be distributed among the learners. It is not only for delivering knowledge, it is also for creating knowledge. I think we should appreciate the organizers who have organized this program, today's program and tomorrow's program. We should appreciate them, and we should cooperate them, so that the starting is, I think, good. Ending of this program will also be good. Tomorrow, in ending session, we are expecting that Honorable Education Minister, Dr. Dipu Mani, will be present here. And that will also be inspiring for us. Finally, I like to thank all the participants who are spending their valuable time in our BUTex attending this conference. Thank you very much. Thanks to all. Thank you.
Now, we are going to start a technical session 2, and I would like to request on stage session chair, Professor Dr. M.D. Moshir Rahman Khan, Dean, Faculty of Fashion Design and Apparel Engineering, and others to honorable judges Dr. Riazul Islam and Dr. Mahbubur Rahman.
Bismillahirrahmanirrahim. Honorable Chair of ICTSE 2022, BUTex, and Honorable Vice Chancellor, Professor M.A. Kashem Sir, special Honorable Chief Guest of this program, Muhammad Asaduzzaman Khan Kamal MP, Honorable Minister of Home Affairs, Government of the People's Republic of Bangladesh. Special guest, Engineer Muzaffar Hossain MP. Special guest, Engineer Mastur Rahman, President, Textile Division, IEB. Honorable Co-Chair, Professor Dr. Shah Alimuzzaman, Honorable Keynote Speaker, Professor Dr. Behra, respected deans, heads, my dear colleagues and teachers, dear students, dear participants, distinguished guests, ladies and gentlemen, Assalamu alaikum and very good evening to you all. In this technical session, actually we three are here, Dr. Riazul Islam and Dr. Mahbubur Rahman, and me, Dr. Muhammad Moshir Rahman Khan. We three are here in this technical session too. In this session, actually here is 3 papers. So 3 papers will be presented by 3 authors. Actually, there is very interesting here. Actually, it's an experience for me. Actually, first paper, the first one is the Sansevieria trifasciata, Bagha-chakor. Bengali name is the Bagha-chakor, a potential and sustainable natural fiber. This paper, I think, this paper will be presented by Professor Dr. ABM Abdullah sir, and co-author is the Professor M.A. Khalek, Head Textile Engineering, Prime Minister University. Actually, this is actually very I am facing a big problem for me. Actually, today's 3 paper will be presented by 3 professors. One is Professor Dr. ABM Abdullah and Professor M.A. Kashem. Actually, they are Professor M. A. Kashem is my teacher, direct teacher, and Abdullah sir also, she is my honorable sir. And another paper, is the investigation on wastage analysis of jute fiber spinning using JBO and soybean oil based emulsion. Here is this paper, I think. This will be presented by Shoaib Islam Jiko, Janata Jute Mills Limited, and co-authors are Ilyas Khalil and Ashikur Rahman. And third one, another paper is this paper, I think. This will be presented by Dr. Furkan Sharkar, Associate Professor of DUET. The title of the paper is High Performance Short Jute Fiber Perform and its Micromechanics in Composite Applications. Here is also interesting. The one of the co-author is actually he is my colleague and the co-chair of this conference, Dr. Shah Ali Mujjaman. Actually, the main problem is actually we need to evaluate these all papers. Actually, this is a big problem for me because one of my teacher, another one is my colleague and the co-chair. And another paper, he is my student, direct student here. So actually, there is 3 dimension. Actually, this is big challenge for me. Okay, anyway, let's enjoy the papers. First of all, I would like to invite the first paper, Professor Dr. ABM Abdullah. Please, I request you from our side, please, sir, I request you please present your paper, please. Thank you, sir. Thank you. I think we will enjoy the papers. Thank you.
Good evening, sir. I think this is after 10 years, I have again in this session for a scientific presentation. Last paper I presented in Calcutta University in 2013. And this is I think, long difference. Actually, there is a story before these research activities that the Sansevieria trifacetata bagachokkar a potential and sustainable natural fiber. Actually, this is the plant. Interesting, there is a interesting story behind this research work because I and Professor Khalek now working Prime Asia University. He is the head of the department. I am just a professor. We are there for he is about last 18 years. I am last 12 years. I spent most of my life in the jute research and development. 33 years in the Jute Research Institute, 7 years at Jute Diversification Promotion Center. Later on, I joined Prime Asia University with the request of Professor Khalek. He is my friend. He is supposed to be present today session. Unfortunately, this evening he went Makkah for Umrah. So, the story behind this research, for last 12 years, from the Prime Asia University, more than 3,000 textile engineers, first and we have taught them research and development and planning study. Particularly, it is my favorite subject. Unfortunately, I did not get any single my ex-student or the student wanted to do research. These two boys, Mr. Owen mentioned Sabbir, here in 2018, they are just first year student. They came to my room and told me that, sir, we like to do some research with this plan. I did not see this plan previously. Then I think ফার্স্ট ইয়ারে পড়তেছে তারা আবার গবেষণা করবে কি, আমি বললাম তোমাদের বাড়ি কোথায়, বললো যে আমার বাড়ি হচ্ছে কাপাসিয়া, আমাদের বাগানে এই গাছটা আছে। তা আমি দেখলাম, দেখে চিন্তা করলাম, আমি ঠিক আছে তোমরা আগামীকাল আইসো। তা আমি তার থেকে গাছের পাতাটা নিলাম। পরে আমি বনানীতে থাকি, যে গিয়ে আমার আশেপাশের বাড়ি সব বাড়িতে দেখি এই গাছ আছে। তা আমি কিন্তু এই গাছ তো বনানীতে বাসা আশেপাশে আছে, তুমি পাইলো কোথায়? যে আমাদের বুশ অর্থাৎ আমাদের বাগানে এটা এখানে সেখানে পড়ে থাকে। তা বললো, স্যার এটা তো ফাইবার হয়, আমরা তো টেক্সটাইলে, তাহলে এটা কোনো কাজ করতে পারি না। আমি বলি যে পারবো না কেন, তোমরা যদি করতে চাও আমি তো চাই, কিন্তু আমি তো পাই না কেউ গবেষণা করতে চায়। নোবডি ওয়ান্ট টু বি এ গুড রিসার্চার। প্লিজ ডোন্ট misunderstand me. I am still with Jute Research Institute interaction in various ways. Government of Hasina giving enough money for the research and development. Unfortunately, very few people are doing research. That is very unfortunately. In Freimacher University, we have in fact, there is no research facility. Still, we are trying to do some work. When these two boys give me this one, then I have thought, when I was in the Dhaka University probably in 1960-64, but at that time, Professor Day, he was the then only DSc in chemistry department in Dhaka University. He used to work on the natural material, particularly these sorts of fiber. I went to Dhaka University and searched whether sir have done any work on this paper. No. Then I see Scientific Journal of Dhaka, particularly Jute Research Institute, Science Laboratory, and the Agriculture University, whether they have done any work on this plant. No. Then I thought, what had done India? Then I find out that, India, Nainital, it was there. They have done some work on this paper, on this plant. Then I asked these boys and teach them how to review literature, and they find out the review of literature, and we started to plan to how to work. At that time, Corona is started. Then everything became hotspots. One of the most problem of this literature that this fiber is different country has different name. In some country it's called the snake fiber, snake plant. Some country it's called the mother-in-law tongue. Some country is still the St. George short. And our country, it is called Baka Chakra. In fact, I learned from these boys, not from me. I did not know this name earlier. In fact, the India, Indonesia, Brazil, and other countries in সবচেয়ে ওয়ান্ডারফুল আশ্চর্যজনক কথাটা হয়েছে যে আমাদের দেশে এই প্ল্যানটা যে আরবানাইজ গুলশান বনানী আরবান ডেকোরেশনের জন্য এটা চায়নার থেকে ইম্পোর্ট করে। এটা কিন্তু ওরা জানে না। আমি যখন ওদেরকে পেলাম, আমি হাঁটতে হাঁটতে ঘরে ঘরে ঘুরে ঘুরে, আমার বাসা বনানী, সেই জন্য আমি এটা সহজ দিয়ে এটা পাচ্ছি। তো আমি লিটারেচার সার্ভে করে দিলাম। এটার একটা ওয়ান অফ দ্য মোস্ট আউটস্ট্যান্ডিং প্রপার্টি ইজ দ্যাট ইট হ্যাজ এ ফটোসিনথেসিস প্রপার্টি অফ নাইট। ক্যালসেন মেথডে এটা রাত্রিবেলা এটা করে ফটোসিনথেসিস করে। সেটা যদিও এই ব্যাপারে সায়েন্টিফিক মহলে দ্বিমত আছে, বাট সিএম প্রসেসে এটা কলোসেল অ্যাসিড মেটাবলিজম পদ্ধতিতে এটা করছে। এটা দিয়ে ডিফারেন্স অফ ওপিনিয়ন আছে, বাট ইট ইজ ট্রু দ্যাট কার্বন ডাইঅক্সাইড is changed to oxygen by this plant. And that is why it also purifies the atmospheric condition of cleaning oil, aldehyde, benzene, toluene, these things, and that is very, very important. Now, I have seen that it also used in China and America, particularly Brazil, for extracting fiber and use various textile areas, and particularly bowstring and the fishing lines and composite and nanotechnology, these areas they are using. In fact, it is a perennial plant and it is a leafy plant. It is a lignocellulosic fiber. So when it is lignocellulosic fiber, then I have got more interested because my jute is also lignocellulosic material. Then I thought that I can do something with this plant. Then one thing, how to extract, how to rate. There are many ways. This plant rating, it is dew rating, mechanical rating, extraction of fiber. And you know, the Bangladesh, amra pate jag dei. Pate that is eradicated, their microbial activity is affected. Then I thought that in most of the paper, they have water rating and the mechanical extraction of fiber, this fiber. In the water rating, they told that it is take about 8 to 9 weeks. Unfortunately, in jute also, we are not at that, only 2 weeks in the jute need. Then we started to find out how this can be, some plan should be made. The planning of the research is fundamental. Before, for planning, you have to know the information. Then we have to take the information of jute, information of coir fiber, information of banana fiber, information as regards the pineapple fiber. Then the extraction. Then we made a very interesting method. It is chemical, biochemical, mechanical process. We developed one extraction process by which only 3 to 5 days we can, we can extract the fiber. Then the question is arise, yes, fiber is extracted, method is developed. Then we have, you know, in our laboratory, it is very limited or no facility, but still we have done some fiber and chemical and physical and some textile property, micronear, length, extensibility, shining, these properties we have determined, and we have compared with the already the authenticate sample that it is working, our method are working. Then we have utilized this dyeing and finishing, scarring, bleaching with modified jute process. And we have already these things, chalai dekhao, shopguli dekhao. A proximate study of sensitive barrier collected here, and we done the physical, chemical, mechanical properties as you get textile and the composition, and then we have compared with the authenticating values, so that is one. Because this is a proximity study. So proximity study, cannot be a conclusive result. So that is why we made it. It is clear the fiber yield, yes, average fiber number of fiber per single leaf. It is 680 to 720, and the bellied one we find from the literature it is 772. The fiber yield in percentage is 2 to 3 and 3 to 4. Fiber length in centimeter as diameter in micron, elongation, moisture content introduced, and cellulose content 7 to 75. Interested here 70 to 75, and the lignin content is 16 to 8. And it give me the thinking that the jute process may be utilized here for the betterment of finding the weight processing technology of this fiber. Interesting that some nice modifications we can have developed a scouring, bleaching, dyeing of this fiber. And we excellent when these products we have sent to BB Russell, and we have contacted with NGO, Dr. Deepa Loksin and Professor Dr. Talukdar of Agriculture University, how this fiber we utilize for value-added product development, particularly decoration, for purification of the air, so that this can be commercialized, popularized, and activated. One of the most important things that this fiber, this plant is go perennial, and this is any climate. It's deserted, non-deserted, slummy, plumy or non-plumy, all type of soil. Even in our countries, it is in the barrel place, it could be planted. So, a comprehensive project we have to take in Dusso Sastha Kendra, BB Russell and Primacia, so that we can have some popularization and commercialization of this project at this area. Now, one thing, this morning said, আমি আসলে প্রফেসর সাহেবের কথা শুনতে পাইনি যে সারা পৃথিবীতে এখন ন্যাচারাল ফাইবারের প্রতি সবের ডিমান্ড বাড়ছে ন্যাচারাল ফাইবারের কটনের পরে জুট unfortunately I am also responsible for that we could not make useful what the usefulness of jute because jute is biodegradable, photodegradable and non-toxic, non-plastic and environmentally friendly and sustainable. But still, jute we have made it, but we could not commercialize. So many ministers comes and so minister goes, but nobody think for the commercialization of jute. Now the composite, now the time of composite, everybody do composite, but fundamental work of the composite nobody done. Even in India, I have talked with my friends, they also done very limited work about the jute composite and particularly basic information of the composition is not available. Again, this plant and jute and renewable source of biomass and it is a environment friendly, it mitigate carbon dioxide. In Dhaka শহরে আমরা এই যে যদি এটাকে যদি হোম গার্ডেনিং তো করছে এটা থেকে যদি আমরা যে ফ্লোরে বিভিন্ন জায়গাতে আমরা ইউজ করি ইভেন ঢাকা শহরে যে রাস্তায় তারা ডেকোরেশন করে সেই ডেকোরেশনে এই ধরনের গাছ যদি লাগানো হয় তাহলে আমাদের ঢাকা তো ওয়ান অফ দ্য মোস্ট পলিউটেড city in the world, we can get rid of that. That is why, in fact, when we submit this paper to BUTex, I just here to just ask my young friends, please do research for your country. There is no alternative but to research. একটা আমাদের একটা কথা আমরা শুনি যে এটা পাওয়া যায় না সেটা পাওয়া যায় না সেই জন্য গবেষণা করা যায় না আমি কিন্তু এটা বিশ্বাস করি না নেভার আমার যা আছে তা দিয়ে শুরু করতে করতে আমি কিছু পাবই এবং চিন্তা করাই সবচেয়ে বেশি আবুল কালাম ইন্ডিয়ান প্রেসিডেন্ট ওনার সাথে একটা সেমিনারে আমার আলাপ হয়েছিল উনি আমাকে আমি পাট নিয়ে ওনার সাথে কথা বলেছিলাম উনি ঢাকাতে একবার আসছিলেন উনি আমাকে বললেন যে বাবা কাজ যখন করতে চাও কাজ শুরু করো প্রবলেম আসবে প্রবলেম যাবে থ্যাংক ইউ ভেরি মাচ
থ্যাংক ইউ স্যার থ্যাংক ইউ ভেরি মাচ
এনি কোশ্চেন প্লিজ এনি কোশ্চেন যদি আপনারা কোশ্চেন করতে চান আসলে আমি তো শর্টকাট একটু বলতে চেষ্টা করছি এনি কোশ্চেন ইউ ক্যান আস্ক মি ইয়েস Yes. Yes, any question. আপনি আমাকে যা ইচ্ছা তা জিজ্ঞাসা করতে Yes. It is suitable. Yes, I told you that proximate analysis was made for textile use and other chemical composition, and it is valid. Now for systematic study is needed.
Right.
Systematic study is needed. Anybody you can do it. That is why
So
I
this
came
is
here.
this is interesting, sir. I'm experienced with actually dealing with a lot of jute fibers and mechanics, particularly with the physical and mechanical properties, sir. So I'm interested in your project, sir. If you find and if you need anything, sir, any help or suggestion or any kind of collaborative work, I can suggest you, sir. Thank you very much.
All sorts of help from me whenever you ask me.
Definitely, sir. To bring it in the next level, so we need to.
দেখো বাবা তুই করে বলছি আমার বয়স এখন 80 আমার মনে হয় এখানে আজ পর্যন্ত সকাল এই দুপুর থেকে যারা আসছে সবচেয়ে বেশি বয়স আমার কারণ আমার ওয়াইফ আমাকে আসতে দিতে চাইছিল না যে তুমি তো হাঁটতেই পারো না তুমি আবার বক্তৃতা দিতে যাচ্ছিস আসলে ব্যাপারটা হয়েছে কি যখন রিসার্চ সম্বন্ধে কথা উঠে তখন আমি বাসায় বসে থাকতে পারি না এখনও আমি রাতে অনেকক্ষণ এখন তো আমার গবেষণা করার কাজ নেই পড়াশোনা করি আর মাঝে মাঝে এখানে তো কেমিস্ট্রির অনেক মহতি লোকজন আছে কেমিস্ট্রি বা ডেভেলপমেন্ট এত কিছু হয়েছে এখন ইউটিউবে দেখে আমরা অনেক কিছু বুঝি না বলতেছে অ্যান্টিপ্রোটন প্রোটন এগুলি কিছু নেই তাইলে আমি কেমিস্ট্রি কেমনে চলবে তো এইসব ব্যাপার দেখে আসলে সায়েন্স অ্যান্ড টেকনোলজি এত উন্নতি হচ্ছে সেখানে আমরা যদি পিছনে পড়ে থাকি তাহলে পিছনে থাকবো খালি অভিযোগ জুট রিসার্চের 40 বছরের জুট রিসার্চে কাজ করছে খালি অভিযোগ কিন্তু ইন্টারেস্টিং কথাটা হয়েছে 40 বছর বা 50-60 বছর আগে আমরা যেসব কাজ করেছি কাজ করে পুরোটা করতে পারি না সেগুলি দেখি রিসার্চ যেমন অ্যাক্টিভিটিস সার্কেল পাঠ করি এটা আমার জীবনের প্রথম ওয়ার্ক জুট রিসার্চ ইনস্টিটিউটে সেই পেপার যে কোথায় গেছে আমি জানি না তারপরে এই সব ঘটনাতে বলে লাভ নাই
থ্যাংক ইউ স্যার ফর ইওর নাইস প্রেজেন্টেশন স্যার
থ্যাংক ইউ পাটের সবচেয়ে বড় প্রবলেম হচ্ছে ফটো ডিগ্রেডেশন সেই উপরে কেউ কাজ করে না থ্যাংক ইউ ভেরি মাচ
থ্যাংক ইউ Our next paper, the paper title is Investigation on Wastage Analysis of Jute Fiber Spinning using JBO and soybean oil based emulsion. This paper will be presented by Mr. Soeb Islam Jiko. Just please come up for presentation, please.
Assalamu alaikum. Good evening. Firstly, I would like to thank all to giving me such opportunity. Today, my topic is the investigation on wastage analysis of jute fiber spinning using JBO or soybean oil-based emulsion. I am Shoaib Islam Jiko, the main author of this paper, and my co-author is Ilyas Khalil and Mr. Ashikur Rahman. And here is my presentation outline. And actually, jute is a coarser multicellulose bast fiber, mostly produced after cotton. Cotton as a natural fiber, jute and jute products is around 30% of overall export currency in our country. In past, it is the first export revenue in our country, but nowadays it's very decreasing day by day. And the commercial jute fiber is mainly obtained two kinds of plants, namely Corchorus capsulus. Physically, jute consists a bundle of fibers held together by hard coating substance. The individual fiber made a large number of ultimate fibers. And here the microstructure of a jute, and the jute is mainly contains mesh structure, and this is a longitudinal view of
a microstructure of jute fiber. And if I say the if I see the microstructure, firstly, the jute bundle after rating, we get the jute reed, and here is the jute microstructure. And if I say the physical properties of jute, the ultimate physical properties of jute is length is around 2.5 millimeter, and the diameter is 18 micron. And single fibers jute length is 0.2 to 3 inch, and the linear density in text 1.9 to 2.9. And we know that jute is very hygroscopic fiber, and at 65% RS jute moisture absorption percent is 12.8%, and desorption percent is 14.6%. And the table shows that the chemical composition of a jute fiber. Jute is mainly a cellulosic fiber. Around 65% amount of cellulose are here, and the hemicellulose is 12%, and lignin is the third composition of the jute is around 12%. Here is the symmetric diagram of lignin, and in this investigation or in this experiment, we are considering there are generally three type of wastes. In our jute industries, there are two type of mainly wastes. One is jute to jute wastes, and another is total raw material wastes. Here we consider jute to jute wastes. If I say jute to jute wastes, mainly three type of wastes. The first one is caddies, and second one is sliver and thread wastes, and last one is floating dust. And what is the caddies? Caddies is unstable short fiber, which is mainly generate the dropes in carding section or spinning section. Generally it's free from foreign particle. And the sliver wastes, here the sliver wastes mainly depends on the machinery's machine condition and the unskilled worker and others. But here the immersion agent is not impact on this. The floating dust or invisible dust are seen surroundings of the machine being floating during the process. And if we see that this is a generation of caddies, and the picture A shows that it's breaker card caddies, and the B picture is finisher card, and the C is that spinning frame caddies, and our and picture A is generation of invisible dust, which we cannot see. It is surrounding by the machine. And B is the sliver wastes of a spinning frame, and C is the thread wastes. Normally the thread wastes is hard wastes. And actually, why emulsion is used in jute? Jute fiber is mainly cannot be proceed successfully in dry condition. For this reason, we have to soften it and lubricant it for further process in carding section as well as spinning frame. After softener and spreader, the emulsified jute fiber bundle are kept under the cover by the Hessian bag or like carpet bag. This section is called piling. After piling, actually, why we used on SBO? Actually, SBO is soybean-based oil. Many industry use JBO, and many industry use RBO or any other vegetable oil. Actually, the jute products bag in foreign country like European country or like Canada, they used jute bag for food grade food carrier bag, and for this reason many buyer they required to hydrocarbon free agent emulsion. For that's why they recommend using vegetable oil treatment. In this section we use in Bangladesh we use soybean oil treatment for its availability and cost friendly. If I say in India, they use castor oil for his availability and for his availability. And in material section, we use jute basing oil and soybean based oil. We use the same percentage of batching oil, and emulsifier is 0.04% and water is 87.96%. Actually, we use emulsifier as a basica, which we import from Taiwan, and the RVO, the JBO, which is jute batching oil, which we collect from Megda Petroleum, Chittagong, and the soybean is our local purchase. And this is our actual recipe. And if I say the chemical process of jute fiber, firstly we take 2 ton raw jute, then in bundle form, then we cut rope cutting, then we bundle take out, then after root cutting, then we grade it. We take here 60% BTD1, BTD3 hard and BTD3 jat. And then after that, in spreader section, we use this emulsion and breaker card, finisher card, first drawing, second drawing, third drawing, and spinning frame. And our SOP is firstly we clean the total machineries, then we input it and take the real measurement in every section. Then we consider moisture by using moisture meter. And here is our standard moisture as adjustment. After that, firstly we consider the moisture as adjustment, because we know that jute is very hydroscopic fiber, so it absorb or dissolve moisture very fast. If I say for emulsion in JBO, the spreader section when I give input is 18.4%, and our final moisture is 17.1%, and the soybean oil is for 18.7%, and last final moisture is 13.9%. And here is our the wastage calculation. The wastage calculation is mainly the input minus the output, and the result and discussion. If we see the KDIS analysis, for SBO for SBO-based emulsion, we see that around 2.5% is higher wastage than JBO. So what is the reason behind it? Actually, the possibility reason is that the highly viscosity and the low lubricity of the SBO. And another reason is the esterification of fatty acid of soybean oil and the hydroxyl group of lignin may occur, which may causes generation short fiber. And for the spinning, for the floating dust or invisible dust, if we say the breaker carding is 0.9% higher and the sliver spinning is 1.18 higher than JBO. So we see that the SBO's wastage is much higher than JBO. Next one is sliver wastage or thread wastage. Generally, sliver wastage or thread wastage not depend on the emulsion. It depends on the unskilled work, machinery's condition, or less supervision or others. So in this section, we see that the JBO percentage is higher than SBO. So here is the total process-wise wastage. Here we see that the process-wise wastage is much higher on JBO than on SBO than JBO. Then it is the category-wise wastage analysis. It is obvious amount of KDs and floating dust, where is 2.5 and 2.23 is higher than JBO-based emulsion. If we see the overall wastage, JBO-based and SBO-based emulsion were 17.9%, and if we see the 9% and 21.2% respectively, the overall amount of wastage of spreading to precision winding is, we see that 3.36% is higher case of SBO-based emulsion treatment than JBO. Here we have some recommendation. In our application, we consider two type of emulsion, but we can consider RBO or glycerin or like that. Actually, we experiment this on his Janata jute mill, not in a lab, university lab or any lab. So it's a, I think it's a bulk production related experiment. Numerous physical and chemical properties of jute yarn can be analyzed after using JBO or SBO-based emulsion. Economically, processes feasible of using other vegetable like rice bran oil, castor oil, sunflower oil can be used compared with JBO and RBO. Here we have some limitation, like we don't consider about the machine condition or unskilled workers or any other. So we have some limitation on this, and we are trying to some experiment with glycerin or others vegetable oil. So generally, this paper is held for the industry owner to make his economic decision. So here is a conclusion. Thank you all. If any question.
Okay, thank you, Mr. Soeb Islam Jiko. Just I have one observation on this paper, please. Just your title was the wastage analysis of jute fiber spinning.
Yes.
But unfortunately, actually, we have seen in your paper Actually, in the methodology, you have used raw jute. The raw jute you have collected from bale. Can you show the methodology, under methodology, the flow process?
Yes, sure.
The process you have applied or you have used in this investigation? Just the flow process. Yes, like
Yes,
actually, have you used this flowchart actually for
Yes,
this?
yes, we use this flowchart.
But here is the raw jute bale. Actually,
raw jute bale, then rope cutting, then bundle takeout. After assorting, we enter the raw jute in our mill site. Then after spreader,
no, it's
then
fine. I think your title was the investigation on wastage analysis.
Yes.
So I think you should have to use the wastage of jute from the starting point as the raw material.
Yes, raw material. Now, actually, the raw jute bale and the jute assorting shed.
No, then process is all right, but just
yes.
Okay, it's fine. Thank you.
Yes, thank you.
I think this is fine. Thank you, Mr. Jiko. Our next paper will be presented by, I think, Dr. Furkan. Dr. Furkan Sharkar. The title of the paper is High Performance Short Jute Fiber Perform and its Micromechanics in Composite Application. Dr. Furkan Sharkar, welcome please. Please come up to present your paper.
পাওয়া যাবে মাইক্রোফোন লাগবে আচ্ছা দিচ্ছি তো তুমি 7:17 বাজে চেষ্টা করো 7:30 মধ্যে শেষ করো হ্যাঁ 7:30 এই মাইক্রোফোন হ্যালো এটা
Hello. Thank you very much. Starting with by the name of Allah, the Great Merciful. First International Conference on Textile Science and Engineering, organized by Faculty of Textile Engineering, Bangladesh University of Textiles. In this program today is present Honorable Session Chair, my Honorable Teacher, and also my Supervisor, Professor Dr. Moshir Rahman Khan sir. Present my Honorable Teacher, Professor Dr. Shah Alimuddin sir, Professor Dr. Mominul Islam Dalim sir, distinguished guest, international participant, and also my student, Assalamu alaikum. And I would like to warmly welcome to my presentations. As you can see, the title of my presentation is High Performance Short Jute Fiber Perform and its Micromechanics in Composite Application. It's basically one of the work of my research group, which is led by me in my university, Dhaka University of Engineering Technology. And the student is Nazrima Sultana. He is one of my senior Apu. Thank you very much, Apu, for selecting me as a supervisor for your work. And before I'm presenting, I would like to talk about a little bit of myself. My name is Engineer Furkan Sharkar. Currently, I'm working as an associate professor in the Department of Textile Engineering in the Faculty of Mechanical Engineering at Dhaka University of Engineering Technology. And as you can see, a little bit of my background, academic background, and my affiliates. I did my bachelor from Bangladesh University of Textiles in 2010. And after that, also, I received my MSc in Materials, Advanced Materials from University of Bolton under the prestigious fellowship, United Nations. And after that, I also received my PhD in Material Science from the University of Manchester under the Commonwealth Scholarship. Currently, basically, I'm leading my research group based on the composite materials. As you can see, I already awarded 5 of my students, MSc students, their MSc degree. Currently, I'm supervising 7 students. Also, one of the PhD students has selected me as a potential supervisor for his PhD thesis. Let's come to the point. Basically, you know that the world is struggling at the moment about sustainability. All the researchers and scientists around the world basically finding a way how to replace the structural materials based on the novel bio-based materials. And as a part of it, I've also selected this topic to select the jute fiber, which is abundantly grown in Bangladesh as a potential materials for using in structural applications. There are some tremendous benefits of jute fiber for choosing it in structural application. As you can see, this jute is one of the strongest and cheapest of all different natural fibers exist in the world. And it has also some excellent mechanical properties like the stiffness of the materials, tensile strength, some heat and fire resistant properties, and most importantly, damping power, which is one of the essential requirements to replace traditional materials in composite applications. And most importantly, this material is sustainable, cost-effective, and environmentally friendly. Before the project is starting, basically we were trying to search for the motivation of the work, like what is happening with natural fibers around the country, like the exist materials, what is the physical properties and mechanical properties basically that exist in the materials. And we found that the tensile strength, which is very important for selecting this material in composite application, is suffered with very poor mechanical properties, like the tensile strength is 160 megapascal only, and also the stiffness is like 8 to 10 gigapascal when it is received from the industry. But fortunately, if you select the raw fiber which is cultivated in the industry, like the virgin fiber, it gives you the tensile strength like 300 megapascal and also the stiffness like 30 to 35 gigapascal, which is amazing, to select these materials as a potential replacement of, which is the glass fiber, which is used basically in the stiffness-driven application. All right, so before starting this project work, we also think about the challenges and the problems that we may face in the development of the novel kind of architecture for this project. So we found that the traditional materials, which is received from the industry, basically comes with the twist and cream. As you know, the twist present in the fiber basically doesn't allow you the proper impregnation during the infusion process. Also, the cream present in the fabric basically produce the stress concentration to receive the maximum mechanical properties. So we basically avoid to use the virgin materials, also the textile structure that is existing around the different industry. So that means open-based materials cannot be recommended. So we have to go for the the untraditional materials or the kind of non-open materials which can be used for cost-effective and also the high performance materials can be produced from this material, from this fiber. And also there are some critical points you need to understand in order to develop a novel preform from the jute fiber architecture. That is, for composite application, if you want to get the more mechanical properties, like achieving maximum mechanical properties, you have to utilize the content of the fiber. This is one of the biggest challenge for selecting the natural fibers. In infusion process and also compaction process, you cannot think of achieving fiber volume fraction like more than 30% or 40% for these fibers. But if you want to actually confirm that you want to get maximum mechanical properties, then you have to achieve the maximum fiber content in the composite materials. And another point is the applying pressure. If you apply pressure for increasing the content of the composites, then you can damage the fiber and also you can reduce the mechanical properties. So we have studied what is happening with this phenomena. That means if the fiber content is less, then it is basically dominated by the matrix. If the fiber content is higher, then it is dominated by the fiber. That is already spoken by the honorable keynote speaker. So we are trying to actually get the maximum mechanical properties by optimizing the maximum pressure, and also there are some other associated things that is considered in this study. After selecting the pressure, we went through the fiber morphology. And the traditional fibers basically comes with lot of polysaccharides that basically increase the interfibrillar angle or the elementary fiber present in the technical fiber. So that needs to be taken consideration in the attention. And for that reason, we also we have studied that by separating the elementary fiber from the technical fiber, it is possible to get the maximum mechanical properties of the fiber because of the surface smoothness and also achieving the uniformity of the fiber. So we adopted 3 approaches: increasing the pressure, applying the pressure, and also fiber separation, and overall the modification of the fiber by chemical treatment in order to achieve the maximum fiber volume content in the composites. So therefore, we have, by considering all the critical points, that we have decided that we want to develop a highly individualized and densely packed short jute fiber preform for composite application. And we set the objectives that we have to prepare and manufacture by adopting the different techniques so that we can produce a preform which is suitable for high performance application, and also study the effect of chemical treatment on the mechanical properties of the composites. And also it is very important to validate the experimental data with the mathematical model data, whether it is actually pass the experimental data or not. So we also adopted this technology, this model for checking the validity of the composites. So the main raw material basically collected by myself, I cultivated in my area, and also I collected the fibers, and we basically choose the polypropylene matrices as a potential matrix in this project. And there are some other auxiliaries which is used for the manufacturing of the composites. Obviously, you have to design your experiment. So by considering all the critical points and challenges, we have decided that we use the field-rated jute fibers, and then we treat the fibers, and we'll untreat the fibers. So with control and uncontrol, and we adopted the different mechanical extraction process and chemical treatment, without treatment and with treatment. And finally, we characterize the materials, we develop the composite and tested it, and find and analyze the results. So let's talk about the claim or the development of the preform, how basically we develop this preform. As you can see from the figure that we collected the virgin fiber or the field-rated fiber, and then we applied the mechanical extraction, which is in-house made laboratory equipment, which is basically from a laboratory. And then we got very highly individualized field-rated jute fibers. Basically, all the fibers are in elementary stage, and then we cut it in different length, and then we also develop a the cake-producing device so that we can collect the fibers and also in a uniform way. So this is also a laboratory-made device. And finally, we got the cake. You can see in the right-hand side of the presentations how this cake is made, and also apply pressure. And eventually, we got the preforms, and finally, we made the composite materials. So after manufacturing the composite, we can get the results straight away by doing different mechanical characterization like tensile and bending. But before that, we want to check basically what is happening actually, the properties, whether it is correct or not. So we adopted some few calculations. As you can see, the equation 1 and 2 is basically used for calculating the density and the fiber volume fraction of the composites. And equation 3 straight away use the rule of mixture. Considering the materials, all the fibers are printed in the parallel direction. And then we use the different formula in modified rule of mixture in equation 4, considering the length efficiency factor, also the orientation factor, whether the properties are correct or not. And then we also consider the helping psi equation, which is usually used for short-term fiber, also transverse direction, what is happening with the fiber. And by considering that longitudinal direction, transverse direction, all the properties whether are same or not. So we basically use 3 mathematical model data to fit the experimental data. So we particularly conducted the tensile test, like tensile and bending test, which is known as flexural properties, to obtain the physical property and tensile properties based on the standard STM D6384 tensile and STM D7904 bending properties. All right, so from the figure, you can see the R for basically the raw fibers, and the RB means the developed architecture that is developed in the laboratory, and AT means the architecture that we develop with the alkali treatment, and B means for we apply the binder in order to achieve the homogeneity in the cake for manufacturing composites. So let's talk about the stress strain curve. So from the curve you can see the composite is basically not like the brittle, like the monolithic materials or metals. It shows a little bit of viscoelastic behavior, and this is the beauty of the composite materials. As you can see, the raw jute fibers that we develop in our laboratory with the new fiber architecture, it doesn't give you that kind of mechanical properties like tensile strength is 28 only. It gradually improves when you apply the binder, and also it is when you apply the alkali treatment. So it basically gradually increasing. As you can see from the figure that the tensile properties has increased from 30 to more than 40, 45, something like this. Also the tensile modulus has been increased maximum for the ATB, that means alkali treated architecture by applying the binder. So that there's a little bit of improvement of the properties after different kind of modification. Similarly, the bending properties or the flexural properties, you can see the flexural strength and flexural modulus has been compared in the figure. In the stress strain curve, as you can see, the untreated fibers doesn't give that much kind of properties. When it is treated with different conditions, the properties has increased from 60 to more than nearly 88 megapascal for flexural strength, although stiffness increased from 4 to nearly 5.2 something. So before doing the mathematical data, we have considered some of the physical properties and mechanical properties of different fibers that is produced in the laboratory, like the raw fibers, tensile stiffness is 30 gigapascal. When it is treated with the binder, it gives you 29 gigapascal, and when you treat it with the alkaline solutions, 38 gigapascal is stiffness, and also it is increased to 37 when you apply binder. Significantly change the mechanical properties, like the tensile strength. It increased from 295 to 475 or 480 maximum after applying alkaline treatment and individualization of the fibers using our laboratory-made device. We have considered some of the other parameters like the fiber individual length, fiber diameter, fiber aspect ratio, critical fiber length, and also finally the length efficiency factor for calculating the mathematical data. And most importantly, as you can see, one of the challenging factors to achieve the highest fiber volume content, in our work, we achieved the maximum 45% fiber volume fraction. Ideally, when you use the fabric or something, traditional materials, you cannot get like more than 25% or 30% fiber volume fraction, whether we achieve nearly 45% fiber volume fraction by applying the individualization of the fibers and using the binder to make the preform with the novel architectures. The experimental results, you can see the 5.18 for the untreated fibers, and it increased to 6.05 gigapascal. Similarly, we adopted the rule of mixture formulas. The simple formula, as you can see, the data is not well fitted. But we have to check anything in composite material based on the rule of mixtures. So we check straight away what is happening with the equation, and it is not fitted because a lot of factors, the variables has not been considered. So we go for the modified rule of mixtures equations where we have considered the orientation factors and length efficiency factors, and it completely fitted the data. Similarly, we use the Halpenstein equation. It gives you the nearly the comparable data. So that which means that the claim that we claim in our work that we have produced a high performance, highly packed, densely packed, short jute fiber preform, which can be replaced for the glass fiber application. It is basically validated by the mathematical model data as well. Now the question is how we achieve this, how basically, what are the formula, how it works, what are the mechanics basically working behind for achieving this kind of properties. We check the raw fiber, how it look like. From the image, the optical image in the left-hand corner in the figure C, you can see how the raw fiber, when you see the cross-section, how it look like. When you individualize with the repeated actions like the extraction mechanical extraction process as well as the chemical treatment, you will get completely individualized elementary fiber, which is much needed for achieving maximum mechanical properties. And also the use of the mechanism after fibrillation and mechanical extraction, how the fiber breaks, and eventually how uniform the fiber will look like. So that means we have successfully claimed and also confirmed that how a raw fiber can be used for producing high performance jute fiber architecture for composite application. And clearly from the SEM image, you can see the raw fibers, because of the presence of a lot of polysaccharides or impurities present in the fibers, the diameter is very high, whether after the alkaline treatment and extraction process, the diameter also reduced, the uniformity of the fibers is also reduced. Therefore, we can claim that the fiber basically used in this study has achieved maximum mechanical properties. So now we can conclude that, yes, it is possible to produce a cost-effective and highly packed dry jute fiber preform using the laboratory-made preform cake manufacturing device. Individualization and alkali treatment can significantly enhance the tensile properties of jute fiber polypropylene composites. Application of binder on jute fiber cannot contribute in mechanical properties. However, it helps in retaining the structural integrity of the preform. And modified rule of mixture and Halpenstein equation basically fits the experimental results obtained for tensile modulus of the composite due to the variables, considering the variables like fiber length, angle, orientation factor, ECC used in the study. So in future, if you want to make the composite in large scale, basically we are looking for the funding, so to produce large scale production of the preform and their applicability in structural application of composites. So that's the end of the story of my presentation. So if you like to have any question, any kind of question regarding my presentation, you can ask.
Thank you, Dr. Furkan Sarkar, for your nice presentation. Yes, Azad, please.
So thank you so much for your nice presentation. So could you please go back to your slides, just for the tensile strength.
Sorry.
Yeah. Yes. The fiber volume fraction. Yes, here.
All right.
So especially my question is for the RB.
RB, right.
Yes.
Raw fiber with the binder,
Yes.
Okay.
You see the fiber volume fraction is 39.
Yeah.
But you see here the result is here the last one you see here 7.25.
So this is the experimental data. You just use the the variables which is suitable for the composite materials for short fiber based composites. The results are not uniform for all of the materials.
Yeah. So that was my question. Like you said, when the fiber volume fraction is more, volume fraction is more, so you can have the more mechanical properties because of the load bearing. So could you please explain here what happened?
Oh, yeah. Yes. Thank you very much for asking the very logical question that if the fiber volume fraction is increased, why the mechanical properties is not increased, right? Your question is such like this way, whether I showed the Helpinson equation mechanical properties increase. So the equation basically is not increasing the mechanical properties considering the fiber volume fraction. It is remain the same because the variables you cannot change, okay? But the thing is, experimentally what is happening basically, when you use the binders basically increase the fiber volume fraction, but it doesn't give you the that much kind of mechanical properties when it is arranged in the preform, okay? So the interaction between the matrices and the fiber, that means the interface may be poor because the binder is applied on the surface of the fibers. As a result of that, the load carrying ability may be reduced. So this might be the reason. So there may have many reasons, but as far as my concern, I am understanding that yes, this is basically obstructed by the the modification of the fiber by using the binders. Therefore, the interaction between the fiber and matrix is interrupted.
Dr. Furkan, good to see your presentation. Just want to add one thing. In your literature review or objective, you try to say that woven fabric might not be a suitable component for using in structural properties. But it has been already established that chopped fiber that you are trying to say here.
Yes, chopped fiber, right.
They're not very good in tensile properties. Unidirectional alignment of the fibers, they carry more load bearing in tensile properties. I think your research need to do some comparison between these UD structures and these chopped structures.
Right.
Because these are very randomly oriented.
Yeah.
I think the question he asked, it's the fiber volume fraction, they cannot be controlled in a heavily way, especially when they are in chopped, because they are not in the same alignment. You don't control those because it's already pressed in a cake form. So that's why you don't know it. But yes, it's a very interesting part. But for the tensile properties, I think that unidirectional structure does better, even for the biaxial, 2D or 3D fabric.
Yes, that is absolutely correct. I think we have produced plenty of papers in placing the fibers in a new direction and making the non-woven preform, which is, you can surprisingly see the stiffness reach to 55 gigapascal, where if you use these glass fibers, even the UD glass fibers, I have checked this comparison with the glass fiber even, it cannot reach more than 32 gigapascal. So the problem with the unidirectional with the jute fiber is it's not a cost-effective process. Manufacturing this preform in the unidirection can increase the price twofold or threefold. So we are claiming this high performance in a sense of cost efficacy. All right. So I understand point is placing the fibers in the unidirection, you cannot compare the short fiber. So that's why we didn't bring the attention of unidirectional fiber, whereas we use plenty of fibers, plain fabric or twill fabric, which is extensively used in the composite application. We can replace those materials by applying a simple technique, cake preform, and recommend that in place of this material. By applying this, we can reduce plenty of cost in the composite fields. You understand? Okay.
Okay.
Right?
Thank you very much, Dr. Furkan Sharkar. Our already 3 paper already presented by 3 authors. Yes, thank you.
Thank you all.
Actually, we are very much grateful to our keynote speaker, Professor Dr. Vijay Kumar Behra. Sir is here. Just from our side, actually, we congratulate you and we are very grateful that you are here, sir. And at the same time, Dr. Shommo, he is my student, and he is also with Professor Dr. Vijay Kumar Behra. Also, thank you, Dr. Shommo, and all of our audience. Actually, we feel actually what is happening in the other universities conference. Actually, parallelly, 3 or 4 sessions parallelly continuing. But actually, we have no scope to enjoy all sessions. But actually, we are happy that we all are enjoying the all presenters' papers. Actually, this is very good, I think. We all are here. Here is from all people. Actually, when we go outside, the person who is interested or who is related to this paper, he only he can participate in that program. But actually, we are lucky and we are very much grateful to all of our audience and all of the teachers and respected faculties. Thank you very much from our side. Now, Dr. Abbas, please come up, and Dr. Kanis Farhana. Thank you very much.
Thank you, session chair and session co-chair. You may continue your work. So thank you very much for all the speakers, the presenters, and also the guests, the participants, audience here. Today, we are concluding today's session. We will see you tomorrow at 9 o'clock. We have 3 technical sessions in the morning, and then after that, after lunch, we will have a closing session. And we would like to see you more energetic. I think it's a long day. Tomorrow is another day. We will see you there. Thank you very much.
Thanks to everyone for your kind patience.
Thank you very much. Bye.